And then that'll eventually propagate to here. Oh my God, it's video. Oh, there it goes. Okay, yeah, there's YouTube. And so now I can give it a second because it has to like climatize. It has to get used to being a thing before I can get my chat app to actually see it. That was the other YouTube. Close that. And then you actually first get rid of this and then auto find and activate. Bada bingus. Hey, that was easy. There we go. So we got 2 corgis in the house today, and I have 2 roommates in the house today that are going to be doing garden stuff. So throughout the stream, you'll probably hear motion detected at the front door because I can't seem to deactivate that. I can sleep my phone alerts, which keeps me from going insane. Yeah. The Willow cam. I need to find my painter's tape. I don't want to lose these screws. These screws are for the 505. Usually the way to go with this is you put them in... Oh, shit. No, there goes one. No, we gotta find that. I gotta find that. I heard it. It's right around here. Oh, no. It's entered the cat dimension. There it is. I see it. I see it. You guys could have helped me find that. Unless I have little drug bags, I could put them in. But I don't have little drug baggies. So, I mean, I guess there's one for the knobs for... Yeah, let's use that. Hold on. Yeah, painter's tape is the best thing. You make a little pocket with it, and then you can tape it to the inside of the case, and that way you don't lose. Yeah, drug bags, little drug bags. These bags you get drugs in. You guys don't get drugs? Weirdos. Now, I'm tempted to use my headers on this thing. I think I should probably... Well, the thing is, I don't have the female headers for regular posts. I've got it for the little round ones. So if I outfit Julian's stuff with all of the posts that I use, going forward, will he be able to... I guess he will. He doesn't really do this kind of stuff, so he doesn't need it to be a standard because he's not going to use it like a microcontroller platform. He's going to use it as Ornaments and Crimes permanently, so... I don't know why Julian's so adamant about correcting me every time I say Ornaments and Crimes wrong, or Crimes and Ornamentation, or I think that's what it's supposed to be called. I don't know, I just like calling it the crime module. It sounds like a public education program. Yeah, indeed, stream is indeed starting soon. How are we doing? What did I even do this weekend? I found a whole bunch of stuff. I searched high and low to find things, namely parts that are going to go into Crimes and Ornamentation. And I also ordered a couple of the parts that I couldn't find. It seems like there has to be a stash of Ornament and Crime parts because it calls for a couple specialty things that I had. Like, for instance, this 3-volt regulator up here. I think I ordered I think I ordered 3 or 4 of those because for some reason, I don't know where I found that, but I found a regulator that had the same pinout and put it into this and it works. But then in the bill of materials, they have a specific one that they call for. The 1117, the LM1117 that's in this package with the better heat dissipation, that one I couldn't find anywhere, but there's evidence of me ordering it as well as the DAC, this $20 part right here. That I definitely ordered 2, and I don't know where the other one is. But, and then Smoking Gun, we've got a very specific, and I think I know what I did here, and I'll probably have to swap in the ones that I ordered. A very specific value of resistor. It's designed so that when it mixes with, or when it amplifies or unamplifies 3.3 volts, the math works out so that it becomes the plus minus 10 volts. But anyway, so that resistor is like a 24.9K. 24.9K. I think what I did, and I'm actually kind of remembering now, is I measured a bunch of 24K ohm resistors, and then I got the ones that were off by almost 1K. But I don't think they're quite as accurate. So I actually ordered some accurate ones of those. But I feel like I must have ordered a sleeve of resistors as well in order to build crimes and ornamentation. How did I get this thing together, and why didn't I clean up the flux? That's my question. Why didn't I clean up the flux? It's disgusting. You live like this? This is gross. This is gross. Where did I get that? Because I looked through my voltage regulators. I don't have any of those. And then L1 is actually one of the best pulls of the whole project, because L1, the inductor, is actually from a Blackmagic SSD video and audio recorder that was sent in because the internal fan died. It has this measly little squirrel cage fan that's designed to cool the processor and everything, and that died, and then this died in the rack of heat exposure, and there was no way for me to, like, I can't get under the heat stuff, and that risks breaking the IC under it. There's big old, probably big old FPGA or something under this. It might be custom to Blackmagic, but we'll never know, because if I break this off, it'll probably break the PC, or the PCB, or it'll rip the cap off of the processor, the really nice BGA chip that they have. But anyway, so this is an AV thing, so it's dealing with analogs, and so dealing with analogs, you often find coils. And so right along some of the amplification tracks, I found a second one of these little surface mount, I think it's 100 Henry coils, but it's a coil, so it went where the coil goes, and should be good enough. I don't think Julian's gonna be like, wait, it's got the wrong coil in the power supply. That means that there is a minute possibility of a transient or something. Yeah, I don't think that'll happen. All right, let's see. Screws go with the thing. Yeah, they're gardening today, so there's all kinds of motion detected at the front door over and over and over again. It's going to be a nightmare. A nightmare for me. You guys probably won't hear it at all. We're going to do this first. We're going to do the light first, and then we'll move on to ornaments and crimes, because I want to get the light working in case a channel raids into us, because having that raid stuff in the title at all is baiting other streams to raid, and I want them to have the payoff of the cool spinny light. Why did I buy more MOSFET boards? Why did I buy more of these? What's wrong with me? These are annoying enough that when they break, they can break your project, just because of the way the MOSFETs failed. There was a new, oh crap, what's that guy's name? The British guy who's like really happy and he repairs stuff. He did a whole thing, and he had some FETs, some MOSFETs that he was testing that were sensitive enough that the voltage that the multimeter put into them was enough to flip them. So he was able to flip the FET by just poking it with the probes, and then he would check the number of ohms between the collector, no, not, it's gate, yeah, Mend It Mark. Yeah, that was a good video. I like that a lot. Although there's some of his techniques I would love to comment on. Like, for instance, this amplifier had huge FETs that were on a heatsink. Ow, that hurt. Huge FETs that were down on a heatsink, and then to bend the leads over, he just bent them around the circuit board. And you can see when he was tightening stuff down, as he tightens down these FETs, they were bending the circuit board around. Really shouldn't have done that. I would have put an object there and bent the pin around the object. Like for instance, you could put, hold on, I gotta fish for it. Something like this. A little copper pipe. Just a little pipe tube. I would probably go thinner than this, but what you would do, I don't have any FETs hanging out. Name mixed up with Curious Mark. Yeah, Mend It Mark and Curious Mark, two different. So anyway, you'd lie the FET down like this, put the pipe in, and then bend around that, and then remove the pipe. And then your leads would be much more neat looking. He was just, wang-jangling the solder on there, and it looked kind of sloppy. But that's just an appearance thing. Other than that, he does amazing work. I mean, I can't imagine how much that would cost to have somebody go through at that level and repair a piece of stereo equipment. But I guess that piece of stereo equipment probably was the price of a house. So probably costs as much as a house, even though it's a fairly simple circuit. Those things can, I guess, get expensive. Yeah, really awesome work to see, though. This is what we're working on. I'm going to get that out of here. I got to make sure not to lose some of the parts that I got sitting on this thing. Actually, I kind of just want to get started. Like, we'll just start early. I've only just barely hit play, but I really want to get this thing done, because this has had the limelight for so long. Hello, welcome to the stream. Today we're gonna... I don't know. I don't know what I'm doing. This thing needs to get completed. Curious Mark is one who repairs old test equipment and restoring a bunch of hardware from the Apollo program. Oh, that's cool. That's cool. I really want to resist putting ferals on all these. I know it's like the complete thing to do, like the completionist kind of thing where everything has to be done perfectly, but I don't think this warrants going that far. I don't think I really need to go that far. I just said fart. Yeah, let's... limelight, more like orange light. Psh. Okay, let's get the music out of here. I want to get started. That was a great fade out, Father. Hi, welcome to the channel where our electrical talent far outweighs our musical talent. And we're going to find out as soon as we actually repair some of these damn instruments that keep being broken or not being built in the first place. Hi. Weird thing to say, Bother. Yeah, I know. I don't know what I was saying. Anyway, I was up stupid late last night, and I'm feeling crummy. So we're going to do work today. We're going to actually do work. I got more of these things, these MOSFET boards. Turns out when these things fail, they can fail hard enough to break your project. So you kind of got to be really careful with them. I don't think they're doing a lot of input filtering, because you look at it and you go, oh, they put MOSFETs on a board so that I can switch on and off a motor. That must be like, it must be its own little thing that like protects your circuit from, nope. When one of the FETs goes bad or you wire it wrongly, which is a thing that happens to everyone, not just me, everyone does it, I promise. When you wire it wrong and you blow up your FETs by sending way too much current into them, they will then switch pins together that you never thought were possible and send 12 volts into your 3-volt system. So we put a resistor on the output from our ESP8266, our little 3-volt Wi-Fi enabled microcontroller here. We're not using this one, but this is just an example. But anyway, we put a resistor on the output, and that should probably help curb the flow of current into it. I'm going to break my Amazon Alexa. Oh wait, no, I said the loud part that I shouldn't have said. No, I didn't say your name. Go to sleep. It just said thanks for telling me. Anyway, yeah, the lady back there is going to be constantly telling me that there's motion detected because people are like watering plants outside. It's going to drive me nuts. You guys won't hear it. It's quiet enough. So anyway, these boards, very frustrating. I did not know that they could take out your whole circuit if you put 12 volts into them and then you do something wrong. Boom. So we ended up breaking one of the ESP8266s, and that one was actually my fault for connecting it to 12 volts by accident. Check your power supplies before hooking stuff up, everybody. We're going to check to see which one is still working. We'll repair the circuit a little bit if we need to, and then I'm going to wire it up to a brand new FET board, at which point we will then connect 12 volts to the input and see it turn on the spinny light finally, because it hasn't been able to do that. I don't know why. It's just like that MOSFET failure, it was the only thing that failed, and it put weird voltages on everything. And then I thought other stuff had failed, and we had to go back and test individual components. The second part of today is building the Ornaments and Crime module. This one has a storied past because it used the Teensy 3.1, and during the pandemic, the chip for the 3.1 became not completely unavailable, but it became prohibitively expensive because they didn't manufacture them. And so Paul Stoffrigan, the purveyor of the Teensy series of microcontrollers, switched to a new one, discontinued the 3.1, changed the numbering scheme, which is totally not confusing and is completely hindering all communications with me and my non-technical friend Julian, because I don't know what to call the 4.0, the 4.1, the 4. Blah. But anyway, the 4.0, the Teensy 4.0 is the upgrade to this. It is much more powerful. It's like 600 megahertz, which is ridiculous for a microcontroller. And you can program it with both of the sort of versions of, or both main programs that you would put into an ornamentation and crime module. This thing is cool. It's like a little utility module that has, it's like WarioWare for your modular synthesizer, because it's got a whole bunch of little things that do cute stuff that helps run your synthesizer. So you can make it like an arpeggiator and send it in note information, and it'll send out arpeggios, or you could make it a bass test, or, you know, I've used this to test modules sometimes too. So yeah, really cool little module, and I'm happy to make one for Julian. We got to get this done. And this has kind of stretched my parts storage ability, not really ability, but just stretched my ability to source and have parts, because I should have had all of the parts I needed, including this little guy right here. This little modem is not really a part that you should put into a new design, because this thing is like $10, $10 to $15 for just one chip is ludicrous, and it is not worth that money. But I had to order 2 more. I ordered 2 originally to build this one. I don't know where I put it. It feels like there's probably a bag of parts somewhere in the shop. I'm never going to find it, but it contains the really expensive chip and maybe some other little accoutrements that I was looking for and couldn't find. This little thing I sourced, this is the full bridge rectifier, and I actually sourced this from a power supply. So I went and I took apart a couple power supplies in the power supply bin, and I finally found one. So these little full bridge rectifiers is 4 diodes in one chip, and when you take apart these little wall warts, they're either using 4 individual cheap diodes, or they buy the all-in-one diode thingy, which is also very cheap, but a little bit more expensive than just putting 4 through-hole diodes. It's kind of crazy, right? But anyway, I found one. That was a big search. The second part was the coil, and the coil I sourced from the thing that the other Lone Star sent in, which is a Blackmagic, I think so, yeah. Video and audio recorder. You basically put SSDs in it, and it's a rack mount item, and you can record all your stuff in perpetuity and super high quality 4K, whatever. Well, the problem is the fan. It has a little squirrel cage fan that sits sort of in the corner, and that failed. And when that failed, this thing just kind of stewed in its own heat to the point where the processor went and then died. And so this was unrecoverable. Now I use it as a source of fancy parts because it's got this whole analog section over here. I mean, yeah, digital to write to the SSDs, but it's got analog stuff for all this stuff coming in. So I was able to source like op amps, and I found 2 of those little coil chips. It's not exactly the precise rating of the other coils, so that's going to affect, I don't know, transients in the power supply, maybe? I don't really think it's going to do a whole hell of a lot. But I'm going to put that, the second of those into Julian's module. So yeah, we'll get to work on that. Let's get started. So I got to see which one of these things, because, okay, all the ones that are still in the block I know work. The ones with pins facing upwards may be broken. This one I found in a different bin, which may or may not work. This one probably still works because this is the one that I tested on the breadboard. So I'm going to put, actually this one will go up with all the breadboard stuff, just so I don't lose it. I got a lot of these boards now. We're gonna need a lot of little motorized things. Before we even do this, we need to get the rest of the system working. And then this is one of the broken ones. It's got pins facing upwards, which we will do that to the new board. We'll have to put pins on it. But before we get there, I wanna have a working ESP system. And I tested this on my own. This is the other broken one. I tested this on my own, and by all accounts, I had it working just fine. So let's see if this one lights up. The one with the X on it is not actually dead, I think. Or it might be this one that I accidentally picked up wrong and broke all the resistors. So we may have to resolder this one. And I think the way to do it with the ESP is to keep the resistors on the inside here and solder them so that they're going inwards. And that way, when I pick the thing up, I don't break all the resistors off. It's just hanging out on the solder is fairly weak. But if this is the one that works, then we don't have to worry about that. We won't have to do that. We have a choose your own adventure stream today. All right, yeah, let me get this out of here and just put that aside. I have a whole bunch of ESPs coming in the mail too. We'll have to play that one by ear as well. I think they get here today. What the heck? Come on, there we go. That I would like to replace that wing nut with something. I don't know what yet. I need to find like a big nut. Oh, that's frustrating. This one side of this thing is crooked. My cut wasn't as precise as it should have been. Okay, this thing is very frustrating. You need to put pressure on it and then really tighten this thing down because it's like the cut, this is too strong. This cut here should be a little bit longer and then it would collapse when you... That's going to be very annoying. Here, why don't you grip that a little better? There we go. No, it's still funky. So funky. Okay, anyway, down to 3 volts on the power supply. 11, 10, 9, 8, 7, 6, 5, 4, 3. I kind of wish these power supply modules had much bigger screens, or if I could hook it up to a bigger screen, just so it would be this big bold number that we'd all be able to see. All right, and then I need it to be up a little bit, and I would like to not use, well, I'm just going to have to use the big heavy leads on it. We'll just be really careful. These big heavy leads like bend the wire and stuff, so I don't really like them. If we can rest the... Okay, you know, like... I'm very easily annoyed. Very, very easy to annoy today. What am I doing? Hello? Why is it not? Oh, because the hook is... I can't see the hook. Okay, so we're hooked up. Turn on 3 volts. 3, 2, 1, go. 360 milliamps is being sucked. This LED should turn on. This is the broken one. Oh, we're only at 3 volts, not 3.3. Maybe if I knock it up to 3.3. Okay, voltage, and then 1, 2, 3. Now we're at 3.3. Okay, so it doesn't matter. The whole thing is heating up. This is the one that made a little spark noise. What's up, Madam You? A little spark noise when I turned it on. I think there's an internal short. That sucks because then the good one is the one that's blown up. So let's resolder this one so that I don't... I broke the other one by trying to pull it off of the blue tack, and I bent the resistors all over the place. So we got to get like some new resistors on these things. Well, only the one, the output current limiting resistor is the only one that I really need to do new. Here, blue tack like that. We can flip it over, and then we'll repair all this stuff. The resistors are the first thing to break because they're not really supposed to have anything mechanical on them. So we can just flip them over to the other side and then get that fixed up. And then this is not the iron tip that I want. Take this one out. I did a little bit of testing over the weekend, and I hooked up the individual components of this system, and it looks like they all individually work. One of the microcontrollers did not survive. I blew it up. Shouldn't have done that. But oh, this isn't even on. Should not have did that. And tweezers are here. We're just going to repair this real quick. This job was ill-advised. See, that's just broken. This one was what value? 2.2. Yeah, let me go get the resistor book. I'm just going to desolder the whole thing. VCC, of course, gets its thing. We'll keep that component. We can keep these two. All right, the blue tack is starting to piss me off. It's not actually holding this thing at all. And I don't think we can reuse this because I think the end of it broke off with the when the thing broke away, when the wire broke away. Am I unable to solder? What's going on here? Jeez. What in the... I'm starting to lose my mind, chat. I'm losing my mind, guys. That's it. That's it. That's it. That's it. Nope. Nope. I will not humor this anymore. Captain tape. I will not be subject to this thing farting about, moving around on me. Only problem is I don't have a good place to tape it. So maybe I do have to just suffer it, don't I? I just have to suffer it moving around. Because like here, what I can do is put a big piece of blue tack under that, and that'll hold that. Unless I do, actually, if I do this, and then tape over that, but it's still gonna, no, it's still gonna move with the blue tack. All right, I've got to suffer the blue tack. Hate it, I hate it, I hate it. It's funny, inside the house, they don't have to be quiet. But then when they go outside the house, I get the most distracting thing. But they're really quiet in the house, but then they leave and it goes, motion detected at the front door. And I'm like, shut up. I thought I silenced you. Where did that go? Oh, it's right here. There it is. All right, we're moving these internally because they're just much better suited there. The tweezers have gotten sticky with the flux, and so they're holding on to the resistor and stuff. Oh, there's nothing that annoys me more is when the things that I'm not supposed to be picking up, I'm picking up. I'm picking up what you're throwing down. So my hope is that we build this thing up and then it just works because we haven't blown up the MOSFET board. That's what was plaguing us before. Oh, I literally moved this thing and I put it right on top of the soldering iron cord, which annoys me to no end. So this is the one that I picked up wrong to get it off of the blue tack, and it broke a bunch of the connections. So we're kind of fixing that up. This one is my last working ESP8266, and it is for the blinking light project, the spinning light project, which is where we wire up one of these spinning caution lights, and I'm gonna make a couple of these, but the other ones I can make off camera. This is really annoying me. This is really annoying me. This is pissing me off. It's like my heartbeat will be translated through the camera. Let's try to do the procedure again. Maybe that'll make it a little less crazy. No, it's still crazy. What if I tighten this down? Usually that helps a little. I need like a counterweight or something. I don't know, or like a damper. Like a hummingbird, put a fluid damper on it. It's just because the whole setup is a big cantilever, like it's a big moment arm. So I just need to keep if I rest my leg on the bench, you guys would be able to see my heart rate, my elevated heart rate while I stream, because it would shake just that little bit for my thub-dump, thub-dump. Okay, so those are the two VCC branches, and those will be nice and safe interior. And then I'm gonna get, I don't really want to use the old one. I'm gonna get some new wire, and we'll do the VCC. Oh, and then I gotta put the capacitor. And let me just get a bunch of this stuff. I'll do exposed VCC. And then we got to test it, so I guess I got to put power wires on it so that I can get power to it at all. I'll just plug power into the voltage regulator, and we'll see it come to life. Yeah, VCC is going to have to solder at the pad. I'll do ground and VCC will go in directly, and then the blue wire will come from over here. Why is that still there? I thought we removed this wire. I saw it. I was there. I was there. Ground is just being obstinate. Oh my God, my dog is barking at everything. Why, Willow? Why do you bark at literally everything? Look, there's the end of the resistor. She lets out these like warning barks to stuff, and it's so distracting. If you're trying to like read a book, all you hear is woo, 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 like constantly. Stop it. Shush. She's a corgi. Corgis like barking. Water found in ocean. Ooh, this is a bit of a problem. That's getting pretty close to there. I'm gonna put a little piece of Captain over that, so we're not shorting any of that stuff out. Although, I don't know, it might be ill-advised to do so. What is that pin? Wait a minute. What is that pin? Serial clock. Yeah, we do. Actually, that's CSO. So that's something that we probably want to block. I do not want to be hitting that with VCC, although there may be no repercussions for that. It's probably just a good idea to be safe. So, all right, let's take this, put that here, put the clean part of the tape there. You know what? I'm just going to do one of these. Let's get that down there, and then we'll just do, we're not doing a neat job of this. Always has been sloppy. It's that part. And then over here. And then I'm going to peel it up, do this around. That's just our little insurance policy against shorting stuff out. Oops, that was, well, it wandered a little bit. That'll do. That'll do just fine. Just get my fingernail over there so I can actually push it down and have it stick in. Cool, cool, cool. I don't know, this stuff is like greasy. The blue tack, I can pick up the blue tack with the blue tack, at least, but it's a little bit weird. So I changed in the code, I changed it so we were using the right pinout. We were not before. We actually did not have the right output. I was using pin 4 over here, and I shouldn't have been. I read one pinout and it said IO whatever, IO silver away. Now IO2, they're using a 2.2 kilo ohm resistor. Can I get away with 1K? I guess I'll just put a 2.2 on IO15 or whatever. So 2.2K and then ground. So that gets a resistor. I guess I could just put a vertical resistor right there. Yeah, okay. Where's a 2.2K? What a weird value for that spot. Yeah, we had a lot of family stuff going on this weekend. People flying all over the country. Ohms. No, we need kilo ohms. We need kilo ohms. That's too many kilo ohms. That's way too many kilo ohms. I need much. Great. So this is requiring me to pick every single bin out of here. Of course, it's at the bottom. Open the stream and get a scalpel pointed at me right away. That's right. You don't get a chance to defend yourself here. We strike. We don't do any of that posturing or power level comparison. We just, it's the time to strike is now. You must overwhelm your enemies. And in that case, in that sense, it's chat. Remember, the streamers hate their audience. They hate them. And they want them dead. That's how streaming works, right? I must win at all costs. And I will not back down. I actually don't need to have 10,000 bins right in front of me. Let's move that. It all goes back into the... This is a big stack of these things that's in the back of this thing. It's where I keep all of my 0805 resistors, and I really should just get one of those binders for the 0805 resistors, because my storage method, not good. It's not good. The audience reflects the streamer. Yeah, I've seen that a lot. That is true. It does do, it do work that way. It do be like that. All right, 2.2K goes to IO 15, and then ground doesn't really do anything else but go over to this. So I can just put this way. So I'm going to open this up a little bit. I'm going to use some desoldering braid on it to clean off these contacts. This is the thing that we've been doing over and over and over again, and I feel like I'm going crazy. But now I know that it was the MOSFET. There was, I keep Mend It Mark. Mend It Mark, if you guys haven't seen, Mend It Mark does a cute little YouTube channel thing where he repairs stuff, and this week he repaired a stereo system that probably costs more than your car. And it's just very simple electronics, but he had a lot of really good techniques in there. And one of the things that I noticed was the failure mode of the MOSFETs was also completely deleterious to the working state of any of the electronics downstream of it. Generally, when you have something like the FETs work on MOSFETs, don't they work on voltage and not current? And so a very tiny little voltage can come along and flip your MOSFETs into conducting. That means that just with the multimeter probes, you can actually test the MOSFET and see if it's functioning. We'll do that in a little bit. But when your MOSFETs break, unfortunately, they can be, because they're very, very sensitive to voltages, right? They're very, very sensitive to voltages on their, it's not gate, is it? Is it gate pin? I don't know. They got a weird, the nomenclature changes between FETs and transistors. And so if you give them a wrong voltage, they go, and then they die, like right away. And if you accidentally discharge static into them, they go, and then they die. If a neutron, a free neutron, just floating around in the galaxy decides to bump into it just a little bit, it goes, and it dies. It's like a socially phobic Swedish person in America. They just cringe out and die at the smallest things. Talk to somebody on a bridge that you don't know, the average Scandinavian will cringe themselves into heart failure. That is the MOSFET. That's essentially the MOSFET. You got to be real careful about how you activate them. Why is this being weird? It's just ground. It just has a lot of stuff. Okay, so the resistor goes onto that. And apparently, when the FETs die in a particular way, they can send the full switching voltage to their sensitive parts. And so it'll piss on all of the other electronics in your system, which is really, really bad when you're dealing with a 3.3 volt system. And I think that's what happened to us, and that's why we got all those weird voltages. I'll catch up on chat in just a second. I'm having a lot of trouble with this ground pin. This is pissing me off. What is going on here? I'm going to put a bigger tip on this just briefly. We're lucky we can flip tips very easily. Yeah, there's some stuff that Minimark does that I'm like yelling at my computer screen about. But he does great work. It's really fun to watch. Although the serial killer smile I could do without. I need a shot of him just looking miserable because he's constantly like smiling for the camera and like he's being a good showman, you know? That's what that is. I just want him to be like, fuck it. Just like slam a hammer on the electronics and just be completely miserable. Because electronics are miserable. I hate electronics. No. Where did that resistor go? It kind of flew away. I don't think, is it that one? Yeah, that one's completely brand new. Okay. Every VTuber chatter is a VTuber. What? Hold on, let me go see what was that? Hold on, I have my Twitch thing up. What was that? Why not because? Oh no, that was old. That's from like years ago. 3 days ago. Yeah, okay. Every alert is 3 days ago. Audience reflects the streamer, which means if you watch VTubers, then you are a VTuber. Man, I've seen some crazy VTuber models lately. They're getting good at those things. I was wondering if I should convert my little chip into, like, I don't, people don't like me. People don't like me, chat. They don't. So I don't really collab all that much. But if I were to collab, I wonder if I would have to provide, like, talking PNGs, which I would make out of the Bother logo, but I would need to make, like, probably 4 to 6 frames. One of it talking, one of it standing still and blinking. and those require multiple frames, so I'd have to go back into pixel art. But it would probably be just the Bother chip logo, the one that suspiciously looks exactly like Fry's Electronics logo, but I didn't know existed when I made it. Eventually the rate indicator will be working. This is about the 6th time that we built it. This time for sure, it'll work. I've been told that this would be the last time that we build it. I've been assured of this. All right, there's the 2.2K to IO15. IO2 is our output, so that one needs to get a resistor as well. Where are my resistors? Not here. Let's put this one away and get the one that has the 10K and the 1Ks on it, because I want to have a 1 kilo ohm resistor on this thing, because we learned FETs can fail quite violently, and they can take the rest of your circuit out with them in an unfortunate turn of events. So if we put a 1K resistor on there, the voltage is going to be the same because we don't have a resistor going to ground. We just have a resistor in the path of the pin. From what I understand, and maybe this is a bad assumption, the ESP8266 can assert a 1 and a 0. It's not just pulling it high and leaving it to float. It's asserting a 1 or a 0 on the pin, which means we only have to put a resistor in the path of the FET, and the 0 will bleed back through the resistor and become 0. That can be an issue sometimes, like if your pins go from like a 1 to a float. That sometimes is a thing, so you have to put a resistor to ground on it. I don't think we need to do that here. This is an Arduino compatible ESP8266. I think it will be okay. But the 1K resistor is actually acting as a current limiter. So if the FET decides to go and then die, it will not blow up all of our electronics. It may make them very uncomfortable for a little while. That's the problem we ran into, is that our FETs died and they decided to take out the whole circuit with it, and then it just made it look like everybody was broken. And if I had a current limiting resistor in there, it wouldn't have been so dire. And then I was testing things and I accidentally hooked 12 volts to this thing, and it died. So that is the annoying truth of it all. Okay, so we need VCC. We need to have our big boy. Let's see. I can run ground over to here. I could run VCC over to... Well, VCC is going to come out and up. And then I could put it here, but then it would be awkward. Or I could put the capacitor just on this corner. But that would make soldering to the ground pin annoying. So maybe I'll pull this over to VCC and put the thing over here. Where are thing? What are thing? What do? How are? I need a 100 microfarad, not a... We had a 0.1 microfarad on this. We'll put a 100 on it just to be nice. Just to be nice, because I'm a nice guy. Because we're just gonna be nice. Isn't that nice of us? That we would be so nice? Why do you keep saying it like that? 1 hundo. That's PF. 22 UF is... Why 100? That seems a little... That's big. I don't know. If we just put 22 on there, I think we'll be okay. 100 is crazy. A decoupling capacitor, they call it. But it's 100K. Decoupling capacitor is placed close to the microcontroller, and 100. Maybe that's a typo. Maybe it's 100 nanofarad. Stand alone ESP. Let's 8266 this. We'll do images. I don't even read the AI. I look over it. I don't look at it at all. Schematic. That's a bit much for standalone. Yeah, 0.1, so 100 nano. I think that's a typo on this, 100 micro. What are they putting on the other one? Yeah, it's typo. We'll stick with our 0.1 off. That's a standard decoupling cap. Which, I don't know where it went. You guys probably can't see it at the resolution that I stream. Nope, not there. So it probably fell from the vise and then was casually brushed aside, where it is now living in infamy. A fugitive in his own country. They'll hunt him down because they have to. It could not have gone... fine, I'll get a new one. 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 I should keep them with my 1Ks. Nope, those are miscs. I know, it's like 1 pixel the size of the thing. I'll probably uncover it when I move some stuff around as we're working. We're doing a lot of soldering today, which is great for me. I love doing this stuff. I really enjoy myself. But you guys get all the good visuals of stuff being built. You're on a mobile! Why do you guys do that to yourselves? I can't imagine, only when, like, I was on a long road trip to my brother's house. That's when I actually pulled up a live stream on my phone. That's the only time I think I'd ever do that. I can't imagine. I guess people live differently than you, Bother. Some people are between classes at university and shit. So I guess I can convince myself of why you would do this. How would fixing collab work? You'd fix something and then mail each other the parts. That would be kind of fun, actually. If we did like a black box circuit that the other one had to analyze or something like that. Yeah, I don't know how a collab between creators like that do the stuff that I do, how would that work? I've been racking my brain to try to figure that out. I mean, between Flatulent Gonad and like Notes and Volts and all those wonderful creators that are on Twitch doing this kind of stuff, they sometimes, you know, you see them show up in my chat quite a bit, and I would love to gather some of those on a Discord or something so that we could collab something. But the problem is we are scattered to the wind, and the one thing that's got us over the barrel is the cost of shipping. It's a nightmare. I'm actually going to run VCC out and up, because that way I can have one wire come down like this, and then I'll have the decoupler here. That puts it in kind of a weak position because it's sort of not attached to any of these strong things, but you know what? I don't like that either. I guess I can kind of squish it over here, because that's our output, that's our grounds. Ground is connected to those two and the cap, so it would just be like doot. I can scooch this upwards. Let's scooch this away. Zoomers are good at typing on mobile. I'm okay at typing on mobile too. Although I used to know the, what is that called? The thing where you tap the button multiple times. I was really good at that. I wasn't amazing. I wasn't like totally intuitive at it, but I was good enough. But then swipe typing has been quite wonderful for me. I'm heating this up through the resistor. It's weird. All right, so we scooch over there off of the Among Us. Hopefully that's not shorting out to that pin. T9, yeah, that's the one. That's the ticket. I used to be okay at T9. T9 you could type while driving because you didn't have to see what you were doing or use a hand to swipe. You would just be tapping buttons. And there was a home row indicator nub. All right, so that's strong enough for our purposes, I think. That's a little sloppy. I don't think I like that at all. But I guess it works. I'm just 7 years older than me and hates swipe. Swipe's not bad. It's all right. You can type pretty quick with it. Old people though, yeah. Well, old people try to use it like a code, and it's just not. like people can figure out what you're doing pretty easily, even if they're Zoomers. It's not like an ancient secret. I have to use it a lot with diabetes equipment. It's how you enter the like serial number, the thing you're, or the calibration number, the thing you're putting on. They had it using T9 for a little bit. It was very annoying. Put an alphanumeric code in with T9. This seems misaligned and I don't like it, but I'm going to live with it. Very fiddly work we're doing here, but it's for the greater good. Actually, this is going to be more annoying because I need to hook a wire up to that pin. I can hook it up on the other side, I guess. Yeah, I guess that's what I can do. I guess that's what I can do. When we power it temporarily to see if it works, that's going to be very annoying. Indeed. And then now I've got this VCC running all the way back here. But the problem is, if I move this anywhere else, it's not going... Oh, and this is coming off too. This whole thing is... ESP, shame on you. Make this easier to run standalone. All right, I'm not doing that. Moving this. We'll get you home in a minute here, bud. You come back over. I think when I'm heating this, I'm heating the entire RF can. Because did you see the tape like backed out when I heated up the pad? That's why I've got the big iron tip on here. Okay, and then you stay. Flux on the tweezers, very annoying. Flip this. Yeah, the ground pin is not heat relieved, so I've got to heat up most of this whole thing in order to solder to it. And it's really, really getting on my nerves. With the big iron on my tip. Big iron on my tip. This is the second to biggest. This one has the heater, the larger heater element, and so it's able to deliver all the BTU that it needs without being a giant chisel tip. So it's good for small stuff that needs to get really, really hot. First you get the butter, then you make it hot. Granny's hot butter ice cream. Granny feed or something like that? I forget. What is going on? I can't... Okay, flux. Hello, flux. Hello. Hello. Hello, flux. Just a little dab. This is going to be like a perfect looking joint. John. Yeah, that worked out pretty well. But now it's covered in flux. So I don't like using flux because it's sticky. It's gross. Gets everywhere. Actually, I'm going to move this a little bit more centered. What up, Clarence? Probably be useful if I made a little board that I could just solder to the bottom of an ESP that just had all these elements on it. I was able to run a standalone ESP. Might be kind of useful. BTU is British thermal units, and well, I mean, heat is power. That's why mankind always seems to boil water at everything. Because if you want to get power into something, you boil it, I guess. I don't know. Water is easy to manage, and it holds a lot of energy. So we use it a lot in power stuff. Huh, why is that so long? All right, let's put the component down. So I have something to solder to. There we go. Yeah, so when I get this 505 working, I'm going to find out precisely how unmusical I am. I'm not looking forward to that. Be like, oh yeah, I don't have any music talent. I like music, and I've sang. I used to sing, so I know how to use my voice. But the 505 is not my voice, and I do have to learn a lot of weird skills, like how to use a 505 that don't translate into things like using anything other than a 505, because the 505 is very specific in how it operates. I bought it just because every single review I see is like, you shouldn't really buy this. I was like, but I used to have one. So there's a little sentimental value. Everything that I'm doing to try to aim where this wire is pointing is failing. The wire is just doing whatever it wants. It is just its own entity at this point. According to Wikipedia, it's energy, not time dependent, instead of power, which is time dependent. Okay, interesting. Weird. Yeah, I just know BTUs refer to like anything. Well, just anything. This is full stop on that sentence. They stand for whatever the hell they want to be. But in my case, I was talking about putting energy into a part of the circuit. So I was speaking in BTU as deploying thermal energy. It does have MIDI. What do you mean? Too old for MIDIs? Oh, this is the only synth and not the MIDI controller. No, the 505 is the whole MIDI controller. It's like the whole deal. The big boy groove box that does everything. And my friend got one in 1998 because we were going to try to start a band, and it ended up languishing for much of its life. I think he learned some stuff on how to use it, but he didn't. YouTube wasn't a thing back then, so you couldn't just look up videos on how to properly utilize the 505. And I think the guys at the music store were duping him into buying equipment that he really didn't need. But I was always fascinated by it, and would like to learn learn how to use it a little bit, see what it can do. But I'm not very musical. You guys have seen how musical I am. Not that musical. What the F? What the hell is that? What the I told you guys, Beats Creation is rating with a party of 4. Well, it beats Creation. What do you guys do over there? What are you guys working on? I told you all, chat. I told you that this would bait people into rating me. So we need to do this part of the project first. We need to get the little spinny light working before we embark on the other soldering project, because my title is baiting people into rating the channel, and I love to see you guys here. How's it going? What's going on? Good stuff. Good stuff. But yeah, what we're doing is, this is an ESP8266. If you guys have ever heard of this microcontroller, I don't know how technical you guys are there over at Beats. But this ESP8266 is a very simple little microcontroller. It's $1. It costs $1. So when you put this in use, you can do all kinds of cool stuff using Wi-Fi, because this is a Wi-Fi enabled microcontroller. And so what we've done is we have programmed this to be one of the Internet of things in my dry sponge just took a shit. One of the Internet of things in my shop. And so what'll happen in the future, working on some art and game mechanics for a co-op trading card game. That is cool. Yeah, we do technical stuff here. I'm doing like soldering and stuff in order to basically bait people into rating my channel. So you got played, fool. I have this Node-RED setup where Twitch API stuff comes in and gets filtered depending on what it's doing. And so for raids, what I want to have happen is I want to have one of these spinny indicator lights, these things that do the little wee woo kind of thing, right? They spin around and they light up and they look awesome. So I want one of those things. What's up, handsome? Why are you asking yourself what's up? Anyway, so raids will come in through here, and we have like an activation for it and a 5-second delay. So that turns it on, it'll spin around for 5 seconds and then stop. And so I've got 2 of these lights, and I can keep buying weird stuff. But what I'm trying to do is get the spinny light to do stuff. And so the ESP8266, I have programmed through Arduino to basically just get on my IP, or get on my network and just be on the spinny light topic. And so when I go and set it an activation signal, it just basically turns the pin on and then turns the pin off. Only 5 seconds? We can adjust that. We will adjust that. This is just for testing it, just so that I know that everything's working. We had a hell of a time putting this thing together, though. This should have been a one-stream project. Just a one-stream project, because literally all we're doing is using a little MOSFET switcheroo board in order to switch 12 volts to the little, it's just like a little DC motor and a spring and the lamp. That's it. What's that? 1 second for every viewer. That would be disastrous. How long is it? 1,000 seconds? That would be a disaster. Anyway, so we did a bunch of soldering. We put the whole thing together, and I got it all into here. And we turned it on, and then this thing just turns on and listlessly just keeps going around no matter what we did. So what the hell happened? We tested all kinds of the electronics. I ended up hooking up one of these things to 12 volts, so I just permanently blew this thing up. This one no longer works. That's why there's an X on it. Now I'm rebuilding it. I'm making it a little bit stronger, and then we'll test it to see that it still works. And then we'll hook it up to the voltage regulator to see that it still works. And then we have to be really careful hooking it up to this MOSFET board, because when the MOSFETs go bad, apparently they can do really weird stuff and destroy the rest of your circuits. So that's what we're doing today. Welcome in, everybody. All right, now I'm trying to get this thing soldered up and not look terrible. I'm never gonna have to look at this thing ever again once I get it wired. But you know, you want to do a certain standard of beautification of your circuits. This is just a decoupling cap. It probably doesn't even need to be here, but it's just free floating on the back here. If I get really pissed off, I might put a piece of super glue on it. Okay, so I think we're fully hooked up. All we need to do is give it power and ground at 3.3 volts, not 12, and this thing should boot up and we should see its little light come on. What I'll do is, I guess just for temporary hookup purposes, see, this is so much better because I can now pick this thing up without blowing it up. It doesn't immediately explode. I'll just put wire on the ends, just solder it on, just so I've got a little flexible coupling here that won't break everything when it moves. Where's the blue tack? Flatulent Gonad has been trying to get me to use blue tack more, so I'm humoring him by using this and trying it out. It's doing okay. I've been a little bit frustrated at it, and everything is very greasy as a result of the greasiness of the blue tack. That's not my, okay. I don't have any parallax. I'm looking through this microscope. I'm seeing exactly what you guys are. And that means that none of us get depth of field. No depth of field advantage. So yeah, that's our stream. That's what we do. We hopefully get things together. Once we're done with the spinny light, I will have actually put my money where my mouth is, and if people raid in, they will be actually raiding into a proper fanfare. Wait, which one is that? Is that power or ground? Okay, that is ground. I'll have to get a red wire for the other side. It's so funny because the big like tent pole. This is pissing me off. Hold on. This needs to be a little bit closer to the ground. The big tent pole project here is Burn the Subs. It's a giant board on my wall that will laser etch the name of subscribers onto itself, and it's not running right now. But when it was running, it was a major baiter. It would bait people into subbing to the channel and gifting tons of subs. It was great. The spinny light appears to have the exact same effect. If your blue tack is very greasy, it might be a good idea to knead some cornstarch into it. Oh, I didn't know that was a thing. These are the Brits in the channel. Blue tack experts. Do I have a piece of scrap red? No, I don't. Okay, let me get red. Corn to the rescue as always. I cannot escape corn as an American. Oh, they just, what? Oh, my monitor. No. No. Why did you turn off? Turn back on. What did I do? Oh, geez. Okay. Don't touch the monitor. It gets a little crazy. Yeah, I could probably just knead this into the rest of the stuff. Okay, put this wire back. I think I've got all the wires I'll need on the field. So let's get red wire in, and I'll just cut those for a temporary length. I want to power this up, but I don't want my leads to be all weird. And the leads will be all weird if I don't solder a little thing to it. Because they're heavy and they like to, you know, position themselves weird. So this is just being neat for the sake of making sure that things actually function today. Which is taking time. It's taking too much time. I want to be done with this part. It's a very, very simple circuit, and everything is bespoke. The ESP, we know, can flip the MOSFET board. We've seen it do that. There, jeez. Do. I have that song stuck in my head now. Say, boom, da, coming for your speaker. Those are definitely separate, right? VCC and the RF can. The RF can is at ground potential. Well, I got to make sure that those are separate. Jeez. If they were to solder to each other, this would be just one big short circuit, and it could damage things. Oh, it's because there was a little piece at the very top. I remember that now. I remember that now, like it was yesterday, because it was. No. Yes. Okay, there. And then we need our output, which is going to be on this one. On the resistor, which is unfortunately kind of a weak place for me to solder to right there. I mean, I could put down a little copper. What I want, and a thing that I've not been able to find, is something that's like this tape over here. The tape over there is called Kapton tape, K-A-P-T-O-N. Kapton tape is used all throughout industry, especially in soldering stuff, because it, oh, damn it, this thing's all over the place. It doesn't leave behind a residue. It's a very clean tape. It does not also, well, it has a huge range of temperatures that it's tolerant of, and the adhesive that they use on the tape is too. So you can use it to hold down electronics, which I really should be doing instead of this blue tack. You can use it to insulate pieces of electronics that you're soldering to on a circuit board, which is what we've done here. I didn't want to solder to any of these pads, or have it so that when I bump this, it'll short out. So I put that tape down there as a go-between. I want something that is copper on the top surface, and then the same adhesive that they have on the Kapton tape. I want a copper-coated Kapton tape that doesn't cost a fortune. I think we found this stuff once because some intrepid viewer was like, I know what you need this. And it was like circuit board repair tape. And the circuit board repair tape was the right stuff, but it was insanely expensive. And I don't know why it would be so expensive. I know copper's not cheap, but I mean, come on, right? Where's 3M on that one? Everybody and their dog makes a form of Kapton tape. It's got a, I'm trying to remember what it's called again. No, I don't remember. It's got a chemical name if you don't want to buy Kapton brand, 3M branded tape, or DuPont brand or whatever. There is a name for that material, and you can just buy material tape. I forget what the name is because I'm dumb, but I really want to find, I'm going to switch to the small iron because I think we're done with that ground thing. And the small iron doesn't heat up the whole resistor all at once. Maybe it is corn. Maybe it's just corn tape. Maybe that's what they call it. All of this, everything you see is made out of corn. Maize. I found circuit board repair like sheets of little adhesive traces, but that's more for like trace repair. It's not for what I want, which is basically just being able to lay down. Like for instance, I could make a pad here out of this stuff. This is working, hold on. Oh, because my iron isn't on. Why you turn off? Corn. What? It's delicious corn. See, I walked the resistor out unintentionally because of the surface tension of the metal that we're using. This stream will look real cool in a bit when we finish this thing. You know, theoretically, there it is. Okay. Starting to get pissed off with my iron for not functioning. All right, so we got a 1K resistor on that. I just need to be a little careful with that. Probably should have like looped this over and then I would have had a little strain relief on there. We'll just be careful with it. I'll try not to pull it too hard. It gets bigger when you pull it. Maybe we'll do this like this, and then that can go there. There we go. I've got all three of these coming out of this end. Good. Good. There we go. Nice and neat is the name of the game because we know what the circuit should look like. I want this to be as clean as possible. This is how I do test setups all across the board. The cleaner it is, the easier it is to troubleshoot. So I'm just going to expose the positive and negative. The trigger wire I will keep sheathed for just a little bit. And we're going to give this 3 volts, 3.3, into this part of the system. Here's this. Where's the other one? These are in the way. Wait, what's my positive lead way over there? Okay, here it is. Okay, 3.3 on the power supply. That is actually permanently on. Okay, fine. Power here. And then ground here. And we should see, oh damn it, we should see the LED on the ESP light up. This is drawing 0.6 amp, so that's 60 milliamps, or 6 milliamps, 60 milliamps. Why aren't you getting on my network? Do we have a bad connection? Oh, there was something. Oh, bad ground. Okay, there we go. All right, so the blue light is on. The blue light is on. Keep your eye on the blue light. You can barely see it. It's okay. Let me move a little closer. Ah, my light is getting in the way of my camera. Okay, there we go. So blue light is on. It doesn't matter if it's in focus. And so we get a raid, and the blue light turns off for 5 seconds, and then it turns back on. Okay, so this one works. Good, 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 good. So now we bump the power supply up to 12 volts, but we don't hook it up yet. So now I have an LM1117. Unfortunately, a little bit warm for the purposes that we're using it, but it's well within spec to power the ESP8266. The Wemos, I believe, uses an LM1117. This is what's called a jelly bean part. Jelly bean parts are parts that you commonly use for tasks in electronics. You know what? I think I know. I think I remember where I got. I think I took this off and I put it onto the Ornaments and Crimes. I think that's where I got it from. Was some defunct microcontroller board that was well obsolete. I should have looked again. I probably could have found one today. Well, we'll look in a little bit. Maybe we can find a micro board that I want to end of life kind of deal. You've reached the life cycle. Okay, so I want to hook positive and negative up to this thing, and I'm going to use a technique called wire wrapping. Wire wrapping is when you wrap a wire around something, but you're wrapping it around in such a way that it crushes the corner of the tab. And when the corner of the tab gets crushed with your round wire, it creates a cold weld, and that cold weld conducts electricity really well. So you can have multiple layers of these thin little solid core wires making an entire complicated circuit in a very small area because all your chips can be right next to each other. So you can get some very dense boards out of the thing, out of this technique. And they used it in Vietnam in order to have field radios that were fairly capable and field repairable if you've got enough of a boffin running things that they know what they're doing. I don't think that's generally the case, but whatever. Okay, so 1, 2, 3. Put this all back together, try to keep it together. And then grab one of the 2 voltage regulator boards that I added a little flap to. I'm actually going to take all these off. These come off. Okay, so the deal is in, out, ground. So ground is all the way at the bottom here. So we insert the wire into the tool and into that little trough. And when we spin this on the post, there's a little, you can't really see it, there's a little, like a little push down thing at the end of that. And so that will effectively wrap our wire around the post. I'm using wire wrap because I'm using wire wrap wires when I build circuits, even on perforated prototyping board. I use wire wrap wire to build the circuit. And in this case, I'm able to put this thing together for a semi-permanent installation, and it would be repairable and scalable if I want to do something else with the light, you know, like add stuff to it. I've got the ability to do that. Why am I striking out? There it is. This little hole right there. That's just the slot in the holes so that you can observe the wire wrap wire going in. Where did the regulator go? Through all this trouble to do that, and the regulator's gone. There it is. Okay, found it. Just wanted to show it on the microscope. Okay, so ground to ground. Ashes to ashes. Okay, that all the way down to the bottom. Start moving around and just go until your wire is done. And then textbook wire wrap. So it's wrapped tightly around there, and we've got a little bit of strain relief on the wire. And then I actually need to come in with another ground and come in on top of this, which I think I can still do. It's going to be a little sloppier than I'd like it to be. Who doesn't like it sloppy? Like, come on. All right, so that, oh, we got it. Got it first try. All the way till the jacket stops moving in. I'm actually going to start from the top, and then I'll move it to the bottom. Textbook. Beautiful. So now if these wires move around just a little bit, they won't tend to like flex themselves to death. If I move them around reasonably, that's kind of a stipulation there. Okay, so we can recycle this. No, I don't like it to be chunky like that. Okay, hold on. Let's take that and just do a little one of these a little further. Okay, this will be my hookup ground. My ground. It comes over to here. You can tell when the old guard of the electronics streamers come in and they go, "Oh, wire wrapping. I used to do that in 1975. But the look on the face of the engineers that you say you're wire wrapping something, you get this look, and they're brought back to like their college days 30 years ago. This is still, I mean, this is still a valid technique these days. It's still completely valid. I'm using it right now to build an installation out of because you get these like breakout boards for components and stuff, and the breakout boards, they have like square posts on it. And so if you want to hook your thing up and you don't want to deal with a bunch of those DuPont header things popping off of all your stuff, and you don't want to go full-blown wiring harness, this is perfect. You get a good connection, it kind of stays put. It's a little bit fragile, but not that fragile. Okay, so now we hook this up to 12 volts and we see the whole thing come to life. Actually, I'll leave those leads on because I'll cut them eventually, but right now we have enough exposed that I can hook this thing up. So power supply off. Then I can hook up my hookup wires that hopefully will conduct because I wasn't doing that before. Where's ground? Here it is. Get this all hooked up. There's an LED on this, and then we've got this thing to look for. Why did this thing insists on being upside down? It insists upon itself. Just wedge it into there. There. Now it's not moving. Hey, what's up? Hinky? Took me a minute. We're having kind of a quiet stream, mostly because I'm not popular, but also because we're doing some more cerebral kind of stuff. We're hooking up the stuff that should have worked before. I got some parts in the mail, and so I should be able to get this thing functioning. 9, 10, 11, 12 volts. All right, so we've got a dangerous amount of voltage on the power supply now. How does the tool handle different gauge wires? It doesn't. Wire wrapping is done with 30 gauge wire because generally we're working with like 5 volt kind of circuits. And this solid core wire wrap wire can take a mighty bit of current because it's solid core. Even though it is 30 gauge, it's very thin stuff. But you would mostly be doing like hooking up 7400 series logic and stuff back when this was in its heyday. So it's not like you're powering super high power stuff. Hold on, I got to take a big old sippy. Oh, that's better. Okay. Let's see. And you, of course, you'd have to be aware of the shortcomings of the wire that you're using. We have 12 volts on the clock. I'm going to send it. And then this little voltage regulator is going to go thermonuclear. It's going to go very hot indeed. So let me actually prop it up right here in free space. I want to see how hot this thing gets. It was getting pretty toasty before, so... our output wire is unhooked up. It's undisturbed. It's in its lane. It's thriving. Arm focus. There we go. 22, 24, and 30 are common, or were common, I guess, in the 70s. Yeah, and then you would have a tool that... where did that go? All right, I don't know where it is. I have a stripper that's specifically for wire wrap wire, and it drops like a little triangle thing on it, so you could adjust it for what gauge you use. The Radio Shack one, this literally came in Radio Shack packaging. This is the one that I like just because it sits in a cabinet, and since it's a weird tool, nobody will borrow it and it won't go missing. But then in the hilt of this thing, you've got this little just stock wire stripper that mostly does 24 to 30. I think it's better for 30 gauge, this thing, but this is the typical wire wrapping setup. This is all you need to be dangerous. Well, you also need square headers. You need square pin headers and sockets for your chips that have square pins. Some of them had extended pins so that you could get lots and lots of connections onto them. But this, you could build a whole computer with this. I built this computer. Out of what? These computer parts. Where'd you get the computer parts? Made them. Okay, so 3, 2, 1, 12 volts, go. Okay, blue LED is on. Blue LED is off. 5 seconds elapse. Blue LED is on. Okay, so far so good. Now keep in mind, this is, listen, chat. This is very simple stuff. This is basically flipping a switch, right? It's kind of complicated, although we've done all of the steps already in the past, right? We set up the microcontrollers before to be on my MQTT server, which is on my Wi-Fi, which is run by Node-RED. Node-RED, MQTT, microcontroller. That system we set up specifically because I've got a lot of like chat interactive stuff here. The light was just like an extra thing, the little idea light. But yeah. How abstract can we make a computer is one of those topics that I don't think about often. Yeah, how much can you lineage back the definition of computer to be one transistor? Why does it seem the square pins bit into the wire insulation? Other way around. And it's not the insulation, it's the wire itself. The round here, I can just pull up. I can't type. Oh, come on, there's gotta be like there's always like a big animated diagram, like a big picture. That's the exact one we have. What? There's way too many things pointing to things. Yeah, so this is the strain relief that I'm talking about. All these diagrams are from all the old books. But what's basically happening is that in the corners, that wire is digging into the corner on like a microscopic level and it's pushing against each other, and it actually creates what's called a cold weld. And that cold weld is important. It conducts really, really nicely. But yeah, it's a very clean technique. Not really known all that much because nowadays we either just solder stuff or we use the solderless breadboard to put things together. I remember when the first adding machine got made in 2010 and people were like, what on earth is this? Adding machine for what? Oh, what people can do in Minecraft. Yeah, the thing about like Redstone is it follows slightly different rules, but it's more like it's weird how it actually kind of works in electrical stuff because it's technically a power source, but it's also the wire and it's also you got to know like some pretty heady electronics stuff to work in Redstone. But it's really interesting because it befuddles even people like me. All right, so the yellow wire has to be much longer. We're getting a new MOSFET board, brand new. As soon as I'm able to actually... Come on. Ow! Oh, it's through hole. That hurt. Man. Brand new. We know this one works because it's brand new, which is not really a good assumption. That's actually a fallacy. But still. All right. That's enough of that. Do I want to put posts on this one? I'm going to end up soldering the 12 volt line. I'm going to clip these flush. God, hurt me like crazy, man. It really hurt me. Okay. I guess I will just solder it directly. I don't like the prospect of that, but I mean, it's the cleaner thing for us to do. Plus, I have to solder the plus 12 connection anyway, because the wire wrap wire does not like to share these screw posts, the cheap screw posts. Haystack Calhoun with a watch streak of 7. That's a pretty good watch streak. Thank you for watching. Yeah, I'm spoiling you guys. Well, look at what the last one did. The last one had like a weird transient... It sent 12 volts into our ESP. Like, I can't allow that to happen again. I'm gonna do this on a microscope. I'm gonna do it. Just you wait. Just you wait. I'm gonna do this on a microscope. You guys will see. You guys will see. You finally see what I can do. Okay. So there's that. The trigger signal goes to there. So I'm gonna make. I'll do the 12 volt one first because VN plus is all the way up here. And actually, what we'll do is we'll feed these wires in through one of these holes, not one of the ones that, well, it'll feed it through the ground hole. That way they've got a little bit of strain relief, so the more I move this thing around, the less likely it'll be for this thing to shear off one of its wires. Ooh, too many things in one hole. I'm not making the joke. You guys make the joke. All right. There's that. Now we're propped up. And I've got to get plus 12 all the way to the plus 12 hole. Ooh, maybe that's too much in one. That's kind of like extruding the jacket of the wire. Well, we'll live with it. South gonna do it again. Dun, dun. This connection I have to solder. I can't do like a post on it or anything. Unless I like had... If I isolate that one, I guess I could put a post on it and then I would wire wrap to that. And I'd run a wire over to it. Maybe I could do that for the next one. But right now, I just want to get this done. I need a bigger tip for this. I need a bigger tip. Oh, you guys are in a weird spot. Here, come back here. There you go. Get more of a sense of what's going on. Okay, and then back to here. It got really quiet. I don't know what's going on. Maybe the dogs are being taken for another walk? Something. Okay, we're just gonna go right to there. This is maybe a little irresponsible because the jackets of the wires can rub and potentially something could short out. But that's how I'm gonna do it. I need to refresh the solder before I solder to it. I'm just gonna hit it with a little bit of my rosin core solder, and that'll bring with it some rosin. And that little bit of flux can help this very large trace to flow over. Because I don't see any heat relief on these. So we're dumping all that heat directly into the big old trace. All them BTUs. All right, good enough. Good enough, good enough. This brings ground to everybody. It's going to be rather short. Another day with no notifications. Yeah, some people rely on the notifications, but Twitch can't be asked to have a website that actually functions the way that it should. And then old Reddit went down the other day. I thought that was going to be it. I thought we were done. I was like, oh, finally, I'm free from social media, free from Reddit. Finally, they deactivated old Reddit. It came back up, unfortunately. All right, is that in the right position? I think so. Try that. Hopefully it solders on the first try and doesn't give me a whole bunch of grief. As soon as they deactivate old Reddit, I'm done. That'll be the last social media that I have. Not a great look for a content creator, but still. One can only be asked to deal with that kind of psychic torture on the regular so much before their breaking point. I'll always have you guys. No, I'm still in Discord. It's just God, that shaking is really, really getting on my nerves. You guys are thinking about those means? I've been on Reddit for like 15 years. I was trying to get some of that melted, gloopy jacket stuff off, but it really didn't want to cooperate. And pulling on it just pulled more wire through, which I'll rectify in just a minute. I like beans. I can't believe you would say something so controversial in my chat. Sometimes the microscope, when I initialize it, it gets a little weird. And today's no exception. It's like showing very prominent vibration whenever I bump the table at all. Okay, so in its simplest form, these FETs should be capable of switching 12 volts to a little spinny light, because that's literally all this board is for. I don't know if I like this layout of wires, but I think we should be okay. These wires come in through this little hole here. They hook it up to the trigger signal and ground. Ground goes to this post over here, where ground goes into the LM1117 voltage regulator, 5 volts comes out of the red wire and goes to our ESP, and then this blue wire comes from our trigger, which is pin number 2. So it's VCC, IO15, and then IO2, where it goes to the trigger of the MOSFET board. So this should be it. This should be all negotiated and set up, and everybody is happy, and we're all gonna be millionaires, supposedly. All right. So if I take these 2 wires over here from the board that blew up, this time we're not doing anything special. We tried to do special stuff on the other one, and that's what led to it blowing up. So now we're not doing anything special. We're just doing it straight up the way it should be. This known blown up board I'm going to put all the way over there so I don't mess up. And here we're going to hook it up to V-in and V-. And this is a low side switching element. So what it's doing is it's switching ground out to the load. Share the load, Mr. Frodo. It is freezing down here. It's like 95 degrees out today. And so the air conditioning is on like super duper blast, because anywhere there's a window in the house, the efficiency is tanking on a 90s house. So in the basement where everything is nice and insulated, I've got blast, like industrial air conditioning blast in my face. Just fill the hole with hot snot to make it strain relief. It already is strain relief. When the wire bends, it's going to bend where the jacket is. So that's the whole point of running it through a hole like that before you solder it down. 12 volts on the clock. Let's get this thing hooked up. Go over to Mo. Mo. All right, one there and one here. Now, what happened last time is things were just weird, right? Things just didn't function. We got like 12 volts throughout our whole circuit. And Mendit Mark did a video this weekend, it was like yesterday, where he fixed stereo equipment. And it turns out a lot of the weird MOSFET behavior is the same thing that we saw. So I was really fascinated by that video, because it was like, wait a sec, I've seen that problem before. He's me. I wonder if I should have run it into the holes of that. That would have been a little neater. Whatever, it doesn't matter. Nice, neat setup. Everything's ready to go. 12 volts in 3, 2, 1, go. It is activated. Why is it permanently activated? This light is on though. So what happens when I send it? I'm going to send it a signal, and we'll see if the light turns off through node red. All right, ready? 3, 2, 1, toggle. Okay, that is still on. It's still on. Why is it still on? Huh. Am I the problem? Send it the toggle. Okay, it's messed up again. Why is it messed up again? I can't seem to win this. When I hook it up to the MOSFET board, it just universally tanks. So if I desolder the FET board, why would that be causing a problem? Since this isn't getting on the network, it seems like my toggles aren't reaching it. So I'm going to turn the circuit off, turn this TV off, turn this TV off, turn the circuit off, and then I'm going to desolder the FET board. These things should work at 12 volts, but what if I just take the one lead off? So this is the same problem, sort of, that we were having. And it's not a short, because this thing was drawing 300 milliamps. I say, boom, done, come to speaker. 12 volts back on, 3, 2, 1, go. Blue light is on. I send it the toggle. Turns off, and then turns back on. There we go. So the FET board is doing something that it should not. It's doing something to my circuit. At least you have air conditioning? Well, yeah, I mean, I would be dead otherwise. You'll be dead. What's going on here? It's funny, I could have sworn that I had one of these working with the ESP before. Yeah, I did. We hooked it up to the, on the breadboard we hooked it up, and it worked just fine. So what the heck's going on here? You know, that looks shorty-outy. So right now the system works, but when I hook it up, when I hook the signal line up to the ESP pin, it doesn't work. The LED on the FET board is across the digital output from the ESP. Yeah. Yeah. Let's take a look at the FET board. Yeah, let's take a look closer. These talk about 5-volt activation, but they do work at 3 volts. It's just, I wonder why that's turning on, because between the trigger pin, you've got a 1K going to the one... What the? Code Rush is raiding with a party of 5. Code Rush, it doesn't work yet. It doesn't work yet. I just hooked the FET board up to the ESP and it's doing weird stuff. So we're investigating that. Is it that we're not sending it enough voltage? But we should be sending it, this should not be switching on. I mean, when I turn 12 volts on here, which this is hooked up to, yeah, we don't get anything. But when I hook up this pin, the ESP is not turning on fully, which is weird because we've got a 1K, what do we have in there? Yeah, we have a 1K resistor on it. Or is that, did I put the 2.2? I think I put a 1K on there. Yeah, 102. It's a 1K resistor going to IO2. Double check my code. 2, IO2. Get my multimeter out. I don't know why it does that. Well, okay, so what's the state of IO2 when we start up? LED built-in low. And let's see. I don't know if we'll be able to find it, but... God, is my window open? Yeah, I'm freezing to death. V Snoopy or PWM. Hakenshi dioda. That's Vishnupi Napatenji. 5 to 36 volts. This is killing me, man. I don't know why this is like not working, because we had it working on the breadboard. It was fine. It worked fine. It was fine on the breadboard. I don't think this is in English. 15 amps, 400 watt MOSFET circuit diagram. Hello, I am thinking of building thing. It's like that. That's what I expected. Actually, that's not what it's like. Wait a minute. Oh no, yeah, this is correct. Okay. Max current, you can determine if the heat, blah, blah, blah. They're just concerned with the MOSFETs. I'm concerned with the switching. Isn't IO2 some boot mode thing? If it's pulled down, it does some other thing? No, I mean, we've got it working. Like the ESP works. Where is that? We're over here. IO15 is pulled to ground with the 2.2 kilo ohm resistor. So yeah, normal GPIO or chip select. So it's pulled low so that we've selected that chip. Enable's pulled high, reset is pulled high, VCC is pulled high, and then ground is also pulled low. So we should have, I mean, the ESP works. If I send it 3.3 volts, that's fine. It's just we have on IO2, which is pin 17, I have a 1 kilo ohm resistor and then our voltage output signal to the MOSFET. And so at 3.3 volts, this should be, I mean, look, if I hook up to ground and then I hook up to that pin, we can see the 3 volts coming out of this thing when I hit the button. We'll just double check that. I just don't understand what's going on with the MOSFET board because we had it running on, didn't we have the Wemos running it? I forget who was running it. I had it running and I had it switching to the thing, and we had the thing light up when there was a RAID indicator. So it was like textbook, you know, operation of this thing. So why would it not? Okay, hold on. I'm like shivering. It's freezing. I don't understand what happened. Somebody upstairs went, duh, I'm warm. And they turned on like super walk-in industrial freezer mode. I need 4 hands to do this. Can I get some help from the audience? Okay, so we've got millivolts coming out of that thing because it's floating. So I'm going to turn on 12 volts. Yeah. Okay, and our ESP gets up and on the network. Why is there no voltage? Oh, bad connection. There we go. Okay, so we're up on the network. We're at 0.16 for some reason. Should be at 0. So then I go to, oh God, where's Node-RED? I'm trying to operate my computer while holding this thing as still as I can. And I activate. We go up to 3.2 volts. And then when we deactivate, we go back down. Could not be simpler. I'm like pointing towards this board just being cursed. There, that worked. You guys can't see it, but it was toggling. Wait a second. Could this thing be putting it into a weird mode on boot? That might be happening. That might be what's happening. Like if well, unfortunately the soldering iron is kind of a ground. I don't think this is a kosher thing to be doing. Hopefully you don't damage anybody. Ah, shaking. What in the world? Why? Okay. I'm trying to do this in situ, which is really not a great way to do things, but we're in kind of special circumstances here. Nope, shouldn't have done that. Shouldn't have done that. Let's see if I permanently destroyed something. Ah, well, there you go. Shit. I shouldn't have done that. A servo-driven vent damper? Yeah, like if I were to put a strut on something. All right, so we got the raid light is broken permanently, and I'm out of ESP8266s. I'm getting what I was getting at is that by the way, the soldering iron is ground, and so what I did is I accidentally put a very high voltage potential onto the MOSFET trigger pin, which, you know, all things considered, I thought I would get away with it, but I definitely did not. And you just saw instant death of all of this stuff. Instant. Although the funny thing is, oh, maybe it's just bad connection. Yeah, okay, it was just a bad connection, never mind. I just bumped this, so I did actually get away with it. But here's the thing, I'm gonna turn this off, and then I'm gonna solder this one pin on. And we will see it get into the weird mode again, because I think what's going on is when this thing initially comes up, it is activated, and in activating, something is happening where the ESP isn't properly starting up. I think that's what's going on. No, we didn't. I thought it was a magic smoke moment. Things can go bad that quickly in electronics. You touch a pin to the wrong thing, boom, instantly destroyed. But in this case, I did not destroy it. We actually are doing okay. Okay, so now let's see what happens if I turn this back on. See, that turns on instantly. It didn't flash. It just instantly turned on. And if I hit toggle, nothing's happening. I think the ESP is getting disturbed. I think the inrush of current is doing something to this. How do I prevent that? It's a weird problem because you don't often experience that sort of thing. Like if I put a big capacitor on this, let's try it. Let me get like a, well, if I do like a 1.1 UF, if I just grab this capacitor right here and I just throw it right there, I wonder if that will help it or not. Well, having a level shifter to shift it up would be good because this thing operates at like 5 volts. 3 volts is the lower threshold of where it operates, but it operated perfectly when I allowed everything to start up and then came in with the thing. So this thing starting as a short to ground and then becoming an open circuit when it charges might be what we need. If it would please, okay, there we go. Let's just try that. I mean, an isolator would be the best thing to do for this, but I don't feel like I need that level of artistry to get by with this thing. What just happened? I just loaded the iron up with a bunch of solder and then the pin itself didn't do anything. Stupid. Why don't you hold on to that a little bit more? There we go. Jeez, ground pin is fighting me. It's possible that if I just put the power into the regulator first, it would also cooperate more. Let's try that. Maybe that'll do it. I hope. Anyway, I wonder if I put like an actual 100 UF decoupler on the ESP, maybe that would have actually helped it too. This needs to go over here, and then we're observing the blue light. All right, ready on 12 volts. Hopefully we're making good connection. Just do that a little bit. 3, 2, 1, go. Sans Undertale noises. Nyaha! Why is that getting so hot? Why is that getting so hot? Chat, why is it getting so hot? Why is it getting so hot? Wait, it's not hot at all. Oh, maybe because I just soldered to it. Okay, maybe that's why. This thing is getting hot, but that's my voltage regulator. All right, let's test it. 3, 2, 1, toggle. Okay, it didn't work. It didn't work. It didn't work. It didn't work. Try one more time. Toggle. Nope, nothing. This didn't come on. It's not lit up, but our ESP didn't like whatever boot mode it selected or something. Ah! Scared me with that. Whenever somebody says idea, that thing turns on. And I guess it took idea. Okay, so I mean, that pin goes high long enough that this thing is able to charge. I don't think I'm dooming the MOSFET board to non-operation by doing that. And it should still work with 3 volts. So if I sent it to toggle, which it's not actually trying to toggle right now. So this has been, I guess it's coming up into a mode that it shouldn't for some reason. And it's maybe because, I don't know, maybe just because of the way it's turning on. We'll try turning it off and on again. Turn it off, turn it on. Yeah, this just isn't like running its program, I think. Why would that be? It should absolutely be running its program. Because if I disconnect this, turn it off. We made it a solder connection. If it was a clip, this would be much easier for me to demonstrate to you guys. So, disconnected. In its lane, thriving. Let's bring this all up onto the green, so we can see the full operation. Fully operational. No, let's let that float. Come over here with this. Here, let me put them right up next to each other. Okay, so you can see both elements at once. So when I power this on without that blue wire connected, ESP does its little blinky thing, and then it eventually says, I'm online. So when I connect this, nothing bad happens, right? And I'm going to reach with my other arm. I'm going to hit toggle. Here, let me make sure that I've got a good purchase here. When I hit toggle, you can see the LED turns on, and then 5 seconds later it turns off. My connection to it is not very good. So that was the theory of operation, and we were able to put this thing together and make it work and blah, blah, blah. And then I hooked it up together and turned it all on at the same time. And apparently the inrush of current coming to this first did something that caused it to be permanently activated. What in the world? How do I prevent that from happening? Last week, I cut and flattened a bunch of copper pipe to make heat sinks for MOSFETs because I'm using a 12-inch engine fan as a laptop cooling fan. The DDR5 and Gen 5 SSD run too hot. Car parts and computer parts are basically the same thing anyway. That's funny. Isn't that fun? I don't know, but I don't think it needs a bleed resistor though, because it was working perfectly fine. I mean, all I can think is that the ESP is being put into a weird boot mode. Remove the LED on the FET board or switch to another I/O. Would another I/O help it work? Because I mean, we can move to another I/O. What is IO2 doing? Does IO2 have a different task? ESP8266. Oh. Normal GPIO connected to the blue LED. Illuminates on low. And it's also TXD1. Oh, so my using IO2 is the reason that the LED was actually showing us what was going on. I thought I also had an internal LED command. All right, so let's go to IO4. So weird that it would work on one and then not the other. It's like, but why would GPIO2 mess it up when booting? If this is the solution, I'll be very happy. So let's just move to port 4. Tools, port. Oh my God. Spinning light 1 at 192.168.2.200. I think that's the right one, but it could be at 224. Let's just try this one first. Boop. Pooping serial. That's right. The ESP poops out random serial when it boots. I don't. But again, why would that hamstring the whole operation of the thing? What would that do? Poop it in boots. Like I don't understand why that would disable the whole system from functioning properly. But let's move over to port 4 because port 4 is unbothered by peripherals, and maybe that'll get it working. This has been vexing. I don't understand why that would do anything. It's like this thing should be able to be sent like a PWM. Is this working? My router probably hates this thing because it keeps coming up and down. Hey, I'm connected again. Here's an IP. See you soon. Oh, come on. I know you work. What are my glucose level doing? I forgot that I put rice on the burrito that I ate for lunch. Rice has carbs. Here, this camera has it. Boink. Oh no, we're doing good. Hey bud. Why are you still uploading? Or is it done uploading? Well, I guess I'll turn off the power supply and see if the IDE yells at me. No, I guess it's done. All right, it just didn't really give us any indicator that it was doing anything. All right, so Gonad has me on the blue tack. On the blue tack kick. This is my only ESP. If we blow this one up, that's it. When I thought I blew it up before, I was ready to call the whole project. You're also really screwing up that antenna on the very big copper plate. What, this thing? It's fine. Do 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 do. Do 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 do. Do 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 do. Wah 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 wah. Okay, so there's that. I don't want to flex that too much or it's going to break. Oh my god, the corgis have been activated. Barking at something. Something's invading. They're going to stop it. Jeez, wires are getting annoying. Okay, let's solder that down again and see if it boots right up. Oh, actually, first I gotta test it. Hold on, turn this on. Oh wait, I'm not gonna be able to see the light turning on now. Well, let that get on the network and then I'll use the multimeter probes. Actually, if I try to activate it now and the light stays on, that means that it did program. If the light turns off, that means it did not program. The light stayed on. Okay, so it did program. We actually were able to program it over the air. So, all right, so that'll get soldered now. It's not a great piece of logic that I just employed there. It's totally definitive because if the light turns on like that, it also means it's broken. But I think it's okay. And I'm gonna get the capacitor out of there. That would have just debounced our input by whatever time coefficient relates to the 0.1 UF. Get out of there. Get out of there. There we go. Okay, these wires are getting very much in the way. Okay, let's give this a try. See if this does it. It's all because I insisted on using IO2, huh? Let's see. 3, 2, 1, go. Oh, it was thinking. Okay, it's up on the network. So now I hit it with the light, red light active, 5 seconds pass, red light. What the hell? Okay, so because I chose IO2, something weird was happening at boot, and it was tanking my whole system somehow. I caused all the problems myself. It was me. I was the problem. This blue wire is a little bit short, but I'm gonna live with it. Spider! Look at that little guy. That's all those little red guys. Okay. Dead. Kind of want to get another blue wire here. Do I have a longer one? No, I don't. Okay, I'll just keep this then. I'm going to keep this because I really just want to get the raid light working so we can work on other soldering. Okay, 215 generally strapping pins right at boot. Need to check the data sheet or the reference manual that specifies ESP. Good bet it's the case here. The little guide that I had said 15 or 2 was like a serial out or something, but having it as the COM pin, I mean, I just chose it by chance, but it's also the LED pin. Ah, bad pin, bad pin, bad pin. All right, let me get a blue or purple wire. I'm gonna go all the way up here. Whichever one you are. Oh my God, my dog is on a hair trigger today. Ready to corgi out at anything. Data sheet says you done wrong. Well, I mean, clearly I did wrong. Like, that's not up for debate. Okay. Blue wire, red wire. Excuse me. Why is even the wires fighting me today? Get my body off of the bench. I'm kind of leaning on the bench today, which is why we've got all this shaking. Every time I move, it causes a huge earthquake. I'm not that big of a guy. It's just my setup is very sensitive to vibration. Wow, wow, wow. Wow, wow, wow. Oh, that bend is gonna mess me up. So I should have kept it at IO4 the whole time, huh? Good enough, good enough, good enough. Actually, that kind of looks cold welded, doesn't it? I can't do like a strain test because I'll break the resistor. The resistor will just blow up because we're relying on the adhesion of the resistor pad to the ceramic substrate, which is not that mechanically sound. Not indeed trustworthy. Okay, and then I'm going to thread through there. That's why I said it would likely work without the LED on the MOSFET board. The capacitance of the FET gate would be too small and likely not cause an issue. Blah! And then make it look like an open circuit. Strap a vibrator motor on the camera mount and add an earthquake redeem. No! Not just gonna do bad camera stuff intentionally. If my fingers would stop trying to curl backwards while I did this very fine motor stuff, that would be very much appreciated. I guess we'll just go through that one. Do 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 do. Mostly just doing the wiring, so it's pretty. I mean, I could go all the way to this and then loop around and then go to the controller board. So I'm just sending a cluster of wires everywhere. Yeah, not really necessary, but I'm doing it. I'm doing it anyway. Doing it to look pretty. That's all I'm good at. Why the 1K resistor? Because when the FET board blows up, it might expose 12 volts to that pin, and the ESP is very much not 12 volt compatible. And so in order to mitigate current that may not ever exist, it's good practice to put a resistor between your microcontroller and the stuff that it's sending like stuff to. Just a little bit of an insurance policy. Okay, I'm tinning this just without the microscope. Probably should use the microscope just because I have it. But everything is like floating in space, so it's going to be kind of frustrating to see with the micro going. There we go. Please stay in place. Just stay, don't move. Better practice to use an opto isolator? No, that's way overkill. We're already using MOSFETs, so this should be isolating enough, but I guess when they fail, sometimes they get crazy. I mean, like an opto isolator in this would be fine, I guess, but it's just a little bit too much. All we're doing is flipping 12 volts. It's not that big of a deal. Shouldn't need something that extensive. An opto isolator would be essentially another LED on the pin of the microcontroller, and so you have this light gap so that nothing can really get back to your micro. That is very badly soldered. I do not like that at all, but I mean, by that I mean it's not soldered. They're so cheap now. I'm not talking about cost. I just mean effort. And the effort to put a whole optical isolator on that part of the circuit is more than I'm willing to go through for a little spinny light. I have done some crazy things with optical isolators in my day. That's usually source, short gate to source or drain to source and gate. Since your low side of 95% of the time fail to ground, where the 1K might be good, if it's shorted to 12 volts. Ours shorted to 12 volts. I don't know what to say. Ours was quite mean. Okay, we're all strain relieved and everything. Let's just do one last test before I throw it into the actual grinder. So I'm going to... Soldering can be, yeah. All right, 12 volts. Main screen turn on. We get signal. And then all of your base. All right, move zig. All your base will belong to us. And then that turns off. Now, There we go. Okay. This is what should have happened last stream. Hey, what's up? How you doing? All right, power off. Unhook 12 volts. All this stuff goes into here. I may just mount it with blue tack for now. We're not going to involve glue or anything. I just want to get through this part of the stream. So now we hook one side up to one side of this thing, the other side to the other. So VN is on this side. So that's where these two will go. Now let's undo the thing. There we go. We've already set this up with its own barrel jack for input, and then the output goes into these two wires over here. So let's get it all hooked up. And then I'll come back with like hot glue or something and mount everybody. But I don't know what temperature this thing is going to reach in operation. So this is part of the assessment that we have to do is run the thing. We have to actually see it in action. I don't want to solder this board on because we don't know if it'll blow up. I really don't want to have to put ferrules on these, but it's kind of looking like I do. Because they're getting all frayed. Here, come over here. We don't know if we're going to run it at 5 seconds, though. That's the thing. I could change that on a whim. And this thing will heat up and the hot glue won't stick anymore, and then it'll unstick itself and get caught on its own mechanism and get yanked around, and then it's going to start a fire and my house will burn down and Willow and I will have to live out of my car. I don't want to have to live out of my car. Okay? Chat? Is that okay with you? These are a pain in the butt. How about that? They're like, these are really stiff wires, so they don't seem to want to cooperate at all. And it's all in the jacket of the wire. The wire itself is much softer, and so everything's like rattling around and not cooperating, and I got to plug them both in at the same time. But this stuff is not very charitable. Where's the flathead here? That's called spiraling. I'm spiraling. There we go. You got to make sure that these crush properly. Sometimes they'll crush to the side, and then it doesn't actually make the connection you want. Since these are so stiff, they're going to independently, they're going to kind of like sit together in there. All right, so now, God, this thing. You go down there. These two are getting all frayed. This is that super flexible silicon jacketed wire, so it's like got tons of tiny little strands. I like using this stuff though. It's gotten cheap. Stuff used to be really expensive. But it makes soldering so much easier because you can't accidentally melt the wire. All right, hooked up. We've got 12 volts here. And then I'm going to just use copious blue tack to hold these things in place for now. I'm going to leave the voltage regulator floating because that gets pretty hot. So I can't really blue tack it down. We'll just have to influence it to be in an area. And I don't think the FETs will heat up. I don't think they'll heat up very much. Although they do seem kind of warm from our test operation. We didn't put it through a lot. The ESP can get blue tack. It only gets warm. Do it all the way at the front. Keep that away so it can't short out. I don't want the voltage regulator to short out my ESP. Maybe we'll move the ESP away a little bit. Go like back here. Okay, for better or for worse, they're at least out of the way of the mechanical operation of this thing. And so now we test it with 12 volts. So the stripe is the pin, I believe, right? Actually, I don't remember which one is which. Okay, hold on. The FET might not turn on enough, and well, we'll see. Well, if this thing runs anything but, you know, nicely, then we'll know. All right, ohms, and then check the stripe. Boy, my dog is being obnoxious right now. She is barking at anything that moves, and the things that are moving outside are the people that she knows. It's her family. They're outside. She loves those guys. Like, you should not be barking right now, dog. All right, so that's got weird, and then this one should have 0.4. Okay, you guys can't see. This one has 0.4. So the pin is the stripe is ground. It's got about 300 to 800 milliamps that it runs. Like the ESP, when it comes up at first, it really sucks down current, but then it'll almost immediately back off. Oh, that's not supposed to be there. That's supposed to go in the little baggie of screws that are... Where did the baggie of screws go? Actually, wait, what is this one? No, that's from the 505. Yeah, that's from the musical equipment. Okay, 1, 2, 3. Make sure to be neat, or else your whole test setup will explode. Those transient voltages we were seeing were so weird. We saw like negative 10 volts on parts of this thing just because the FETs were blowing up and sending all these voltages all around. I know we're doing synthesizer crimes again. We'll get to, that's the second part. Once I get this thing up and running. Oh my God, dog, shut up. She is going psychotic at the door for some reason. And it's probably people she knows. It's probably the people who raised her. from a wee little puppy, from a wee little corgi puppy with 2 floppy ears that didn't point up at all. They eventually did. One started and the other one went up. And the reason that I think that I'm being monitored, no matter what I'm doing on my computer, is that all of a sudden, the subreddit for dogs with 1 floppy ear and 1 up in the air started showing up. Why did that subreddit start showing up? I've never seen it again. It's never come up again. Only when my dog had 1 floppy ear and 1 up in the air did that subreddit show its face. Weird. Weird. Then again, I'm streaming, so obviously everything that I do is being recorded. All right, 12 volts on, 3, 2, 1, boom. Shit, that's not what it's supposed to do. When the ESP comes up, will it turn off? Oh, smelling, burning, burning, burning. Why? Stripe was to ground. Oh boy, whatever just burnt up, burnt up. Did I immediately kill it? Okay, I just said stripe is ground because I went from here to here and that was continuous. So why would I have burnt up my electronics suddenly? Because I've got power here and ground here. That should have been fine. Definitely smelled burning electronics, so I think we blew up the ESP, but we got to do a post-mortem now. I literally just did ohms, non-stripe. We wired it backwards, or rather I hooked it up backwards. I should have current limited it. That might not have actually affected the ESP if we're lucky. That might have just affected the LM1117. Son of a bitch. I wasn't looking. Stripe is positive. That's what I thought it was, but then I tested it and I thought it was the opposite. That's what happens. With any luck, the ESP was not affected. This should not affect my baby. And maybe just the LM1117 is broken because that's what would have gotten the initial current. The FETs, I hope, are not broken because that's a pain in the butt to swap out. But we got to do a sudden post-mortem on our whole system because everything is so fragile. So this should actually work. Yeah, but we're not drawing any current. And this isn't heating up at all. So who among you exploded? Was it just the voltage regulator? Let me check. There should be 12 volts on the inlet of this thing. With any luck, everybody survived because the FETs were getting power where it was capable of getting that power. And then the ESP would have gotten only ground. So if I check from ground to here, yeah, 12 volts. Oh, sorry, guys. Here. And then nothing. Okay, cool. So that didn't blow it up, supposedly, yet. Let's turn this off. Do I want to rewire wrap all those connections? No. But I do have another LM1117 board sitting around here somewhere. Here it is, this one. So let's wrap this one in, and I'll hook it up correctly this time. Shit. Well, with any luck, the LM1117 was the thing that died, and I have 100 of those in a bin. So got me crashing up your airwaves. I can't get enough of your sound. Said bump da. Yeah. You should just strip these and start over with them with the wire wrap. Yeah, probably. It's going to be annoying because it's kind of close quarters over here. Got to get it working. We got to get it working. So let's cut these. Strip it. What a rookie mistake, huh? What just happened? That just stripped it even further? God damn it. I guess there must have been like a roughness in the wire and it just over-torqued and didn't strip. If there's like a little knot in the wire, it causes problems. So now these have got to be equally short. This is what I get for making it organized. It's not the best wire stripper in the world. It works, sort of, sometimes. Man, that got really stinky. I hope that was just the LM1117. With any luck, it protected the rest of our circuit from blowing up. These things are usually filtered out by competency. We don't have that luxury here. Okay, V out is in the center. Yeah, V out's in the center. V in is up here. That's the yellow wire. The annoyingly short yellow wire. There's like a little bend in the very tip of the wire that's getting in the way. Okay. And then ground. In college, one of our circuits classes, we had to build something that would count up memory addresses as you recorded audio into a converter an analog to digital converter, and then you would flip a switch and hit a button, and it would do the counting again, but this time it would recall all of the memory addresses and send those into a digital to analog converter so that it would play back whatever you said into the thing. And I had a teammate who needed to write our final for our capstone project and couldn't do the lab, so I had to put together this circuit using wire wrapping in like 10 minutes before his ECE lab so that he was able to go and write afterwards. And it worked the first try. All right, so keep this thing away from the metal, keep it away from the spinning parts, just don't get it near anything. This is hooked up properly. I have that hooked up properly. I know it is. Just in case. Ohms from the positive lead to the positive lead. There we go, 2 ohms. Well, 3, 4. The connection's not great because I'm just kind of holding them together. Okay, so now, all things considered, this thing, okay, keep that away from that. Let's get that over there. There we go. You just hang out right there. God, this has been a pain in the butt. A couple little errors, and most of them were caused by me, but also because I chose the wrong pin, and it caused the ESP to get into kind of a weird state when it started up. So now, by all means, this very simple circuit should be 100% functional, and we will have something that will respond when somebody raids into the channel. So 3, 2, 1, power, go. Please, ESP, please. Yes, okay. And then somebody raids. Yeah! And then they stop. Beauty. Man, that should have been a one-stream project, and I guess one-stream projects are always like that, huh? So now we have a raid light, and I could I'm gonna bait the Twitch title. Bait the Twitch title and say, channel raid light active. Done. Yeah. What's up, 71 people? Hey, that's the nice amount. You guys are too much for me. No, you're awesome. Thank you. All right, we got to pack the wires in a little bit. I'm going to keep the voltage regulator floating for now because I don't really have a good place to put it. In most linear regs, there's actually a diode where the output, a diode between the output towards the input meant to discharge the output in a pinch. They're not meant for continuous current, so they blow up quickly. The internal current went through the entire circuit. You're one less lucky SOB, I know. The ESP has been surprisingly resilient to my BS. It's been quite tolerant of all of my bullshit that I've thrown at it. We still lost one of the ESPs though. This thing sucks. How are you supposed to put this back together? Wait a minute. There we go. Ready to put on top of my car. So, we're sitting here, we're having a good time, we're going ha 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 ha, and then somebody raids and I go, huh? Oh my God! Thank you for raiding the channel. That's great. How much current does that take when it activates? It takes up to an amp. That's 800 milliamps in its steady state. But when it first flips on, that I saw a 1 point something. Jeez. Yeah, the LM1117 is pretty resilient for what we've put it through. But yeah, we got the raid light now. Now I need to like put it somewhere conspicuous. I mean, I could put it like here, but then it's not as showcased. I'll leave it on the desk for now, but like in the future, we can, I can find a clever place for it in the room because that'll be better. And then we can also throw stuff into Node Red so that it'll turn off all the lights around here. So the only light is those things going. And I think I probably want to put it right there. One of them right there. And then the other one I can maybe put somewhere else that's pretty conspicuous. Let's hold on. I want to see what the 12 volt LEDs look like in it. God, it sucks. Okay, there. Jeez. I said boom da. You coming through your speaker. Oh, that, no, it doesn't actually hit. It's very strange, though. I think I'll want to go to incandescent bulbs on it. That's going to look crazy. I've got a little toggle button where I can set it off for 5 seconds, but I'm going to make it like 20 seconds. Oh, wow. Holy shit. That's actually better on camera. That's better than the incandescent bulb. Because that's like... it's also taking a third of the current. Steady state was 800 milliamps. This is 300. Audio from the PC like a siren. Yeah, I'll try to figure something out like that. Something that doesn't blast out my eardrums, because having like an actual air raid siren would be great, but those are actually like air-powered spinning elements. Yeah, this looks better on camera. It's throwing more light out. It kind of hurts a little bit, but... Oh my God, the dogs are going crazy. Motion at the front door. Panic at the Disco. All right, cool. We got raids. Wait, we don't want that. Try to work this stuff. Where's the rest of my blue tack? I have a big... Oh, there it is. A big booger of blue tack. No, listen, the decibels that you have to deal with, I'm just not. But, oh. There, so now it's 10 seconds. That'll be a little better. More showcase on the light. Wee-oo. Oh, I love it. I could stick it to the milling machine, but... Yeah, that'll be... actually, I think maybe 20 seconds, because we don't get a lot of raids here. 30? Let's make it 30. I think 30 is good. Yeah, the LEDs look really good in it. I'm actually really happy that I bought the LEDs now. I thought the LEDs were going to look terrible. I thought they would bleed through and everything, but this is now going to go for 30 seconds, so I can really address, I can get to the right camera, and I can really address the person raiding in and go, oh my God! Thank you for rating my channel. Oh, that's so good. And that's going to go automatically. So it'll, the raid message will come up for however long it is. I think it's 20 seconds. My channel is still set up for low numbers. We don't typically get like, 200-300 people here. So when that happens, and I should say when, just to be confident, I'll have to recalibrate all of my alerts and stuff so that they're a little bit faster. Right now, we can kind of dwell on it, which is nice. Awesome. All right. Awesome. We now have a raid light that'll just sit over there. Whew, it's cold. I got to stretch my legs a little bit. So we finally got that working. There were a couple things at play that made this very, very frustrating. One was the pin that I chose was doing something with the ESP that was getting it into a weird mode. So that's why we never saw the ESP come up on any of the systems. The second thing that I did was the MOSFET board failing gave us all those weird voltages that we saw running around, and it was sort of like we weren't used to seeing stuff like that, and I wasn't aware of the failure mode, the exact failure modes of the FETs. It turns out when the FETs fail just right, they can send really weird, spurious voltages all over your system, and that's what we were seeing yesterday, last stream. The third thing was that I connected the power wrong. If you ever do any content on flyback diodes for inductive loads, it might be interesting to see how high the voltage on the MOSFET jumps when you turn the motor off. Yeah, so in electronic systems, a big thing is turning electricity into magnetism. And the relationship between electricity and magnetism is quite well known by mankind. It turns out if you have a changing magnetic field... Oh, do I sound muddy right now? Hold on one sec. All right, that should be better. It turns out that if you have a changing magnetic field in the presence of a coil, that will cause an induced load. That'll create power. What happens in an electromechanical system, like for instance a relay, you have a coiled magnet and you have a physical switch that gets switched by the magnetism by the magnetic field. When you turn off a coil, it'll create a spike in electricity in the opposite direction as that magnetic field dissipates. So it becomes electricity again. We can use that to bump up a voltage level and then smooth it, store it in a capacitor where it can get used at a higher voltage level. So that's how we have step-up regulators. That's how we do it. We put a pulse into a coil and we capture that with a capacitor, and that brings up the voltage level. When you have something like a relay and you want to switch it with very sensitive MOSFETs, well, MOSFETs have their own little flyback diode, but if you want to switch it with a transistor, and you're doing this with like an Arduino, if you send power to that coil and you suddenly cut off the power to the transistor, the coil's going to dissipate the magnetic field in the opposite direction. Really bad for your transistor. It hits your transistor with this massive negative voltage all of a sudden. And so what you do is you put what's called a flyback diode. And so the diode blocks in its normal operating direction, but when the coil wants to create that huge negative spike, the diode is situated so that it's able to allow that current to pass, and it'll dissipate back into the coil. So the flyback diode prevents all of your sensitive electronics from getting hit by weird stuff. MOSFETs, some of them anyway, have a diode built in that helps with that sort of thing. And so the relay board here hopefully is switching pretty cleanly, because sometimes if you're just mean enough to your switching elements, it'll fail eventually, which is a bad scene. You're on borrowed time. So yeah, if an intrepid streamer raids in, we now have this active thing. And now I know how to situate the ESP. I've got a package full of ESP8266s coming in the mail. Oh my God, more motion at the front door. I am gonna go upstairs and punch everyone. Everyone. So now if a channel raids in, boom. How cool is that? I'm gonna leave this here for now. We're gonna work on this thing. We're gonna go work on crimes and ornamentations. I have something set up, Remy, so that if the raid is below a certain number of people, it doesn't show up. I know people can raid from their home channel, and it'll say like one raider. Yeah, so I put a filter on that because I don't want to get like trolled. I want there to be at least one other viewer, one or two other viewers to raid in. So we're gonna let it diegetically become a thing. It turns out I don't know if I really need a 1 amp power supply, but I am gonna need something that can handle 30 seconds of 300 milliamps. This thing made it 800. 800 milliamps, 300 milliamps with the LED. Oh my God, that was a big hiccup. Okay, so let's work on Julian's thing. Inductors are cool. Yeah, I was lucky enough to have an electronics teacher that wasn't afraid to make us disconnect the whole 8-inch spool of magnet wire. Did they make you plug it into the wall? Because we had a lab like that. They said, you guys need to learn how to make a power supply. Here's a transformer. We need you to plug it into the electrical socket. And I'm like, don't they yell at me when I do that? Like, you need the diode across the coil so the current continues to flow through the diode and the coil when the MOSFET is off. The diode and all MOSFETs will not help here. I see, okay. Yeah. Well, I don't know what this circuit itself has, because it doesn't really have a flyback diode, so I don't know, maybe we are creating, I mean, that DC motor is gonna have coil elements to it, and it'll create some dirty things happening on our power. I mean, our power is connected, it's just would create weird ground stuff. They seem pretty resilient to it, but it's possible that we are damaging it every time we switch it. All right, so ornamentation and crime. I have a lot of parts, but I was missing quite a few too. Hold on, let's adjust this thing. I've been using this specific circuit board clamp a little bit just to kind of get to know it. It's been doing okay. The vise kind of struggles with larger setups like this, so it holds pretty well. The circuit board's not really going anywhere. We've got a lot of work to do with this thing. Ornamentation and crime is a modular synthesizer module. My back feels like it's in a refrigerator. I'm gonna move the fan. Hold on, I'm gonna kick this fan out of the way. Yeah, back to crime board for criminal soldering. crimes and crimination, crimey, anti-toss. Yeah. Okay. The fan is redirected. I mean, like, I got the window open, but you can see what's going on here. Look at all the heat that's coming in. Usually we're used to seeing like a dark blue like cascade over there, but that's how hot it is outside. It sucks out there. It's terrible. As soon as the air conditioning leaves your clothing, you're just done. It is a wet heat here in Philadelphia, I should say. Stop playing footsie with your fans. Look, I have a very tiny fandom. Very small indeed. Very small fandom. It's 10 by 10 millimeter. We gotta put this in something. Anyway. Ooh, that's cold. It's so cold in here. What does the thermometer say? 71 degrees? That does not feel like 71 degrees. By the way, that's an on-air light. One of these days we'll figure out putting something over that so that I can have multiple modes on that. And I want it to look like one of those retro on-air lights. My brother had an on-air light and it was in his keepsake box and I think it got broken or something. So I'm probably just gonna have to like design something and make it. I could 3D print something that looks Art Deco enough, right? Do I have a part number for this? This thing was like 20 bucks or 30, I forget. I certainly didn't spend $100 on 3 fans. Let's see. Oh boy. Well, if you can get a screen cap of that QR code, it'll probably tell you what it is. I think this is 20. Hold on, let's get a measurement on it. These things, I saw it on Reddit and then I went and purchased it because I had to have it for the joke. 12. 12 millimeter. So yeah, get a cap of that QR code and get it on your phone or something because I think that'll point you towards what it is. Oh, wait a minute, here we go. Sunon. There's your part number. Is this your card? I see a blur. Okay, get ready to write. UF3C3-700 space TC. And it's by Sunon. And you can rewind the stream if you want to. They don't move much air. Oh, thank you, Legoland. Yeah, there it is. They're expensive too. These are not cheap. And I literally bought it for a joke. I've never needed to cool something that small. I could put it in the raid light. Is that getting? There's a little bit of heat from the regulator. We can see it on the thermals. I mean, I guess that's okay. I need teensy tiny. Well, there you go. That's teensy tiny for you. Why does the LM1117 get so hot? Guess that's just linear regulators doing linear regulator things, huh? Oh man, I did not know. I had, what is it, chicken verde? Like green salsa chicken for lunch with some pretty nice brown rice in a tortilla. I did not know I was signing up for the fight of my life. My heartburn has heartburn. I'm gonna take an acid reducer. Give me one sec, guys. It's not glucose level related, so I'm good on that. All we're really doing is just baiting a raid. I'm just sitting here waiting for somebody to raid the channel so that my dynamic, awesome looking raid light works. And then when I get back to it, I'm gonna make it so that all my studio lights turn off, and then depending on which ones were already turned on, they'll turn back on. Can't really send toggles because then it'll turn other lights on that I don't want on. Synon was founded in 1980 and is a leader in precision motors and miniature cooling fans. It offers the smallest 8 millimeters, the thinnest 3 millimeters. There's a smaller one. Oh man, I should go get that one. I think if you need an 8 millimeter fan, you should probably reevaluate how you're cooling your system. You know, that's time to like, maybe we go back to the drawing board on this one. Crimes and Ornamentation is a modular synthesizer module. I would power this up for you guys and show you, but my 12 volts is currently on the raid light. I will eventually find a wall wart for this thing and then build up a second one so that I have two really obnoxious lights for when people raid the channel. I think that would be very funny. And in the future, maybe I could buy some more. I just keep making them. But Crimes and Ornamentation has basically two halves of it, and well, depending on which, there's like two branches of software that you can use for this thing. And when you use the Teensy 4.0, you can use both of them because that thing is way more capable than the 3.2. This thing was originally designed with a Teensy microcontroller, which is a bristlingly strong microcontroller. Paul Stoffrigan does not F about when he's making like a microcontroller, I don't know, evaluation board. It's like a basic stamp on crack. But anyway, this thing is crazy. There's a lot of processing power. There's a lot of space in it. And so the modular instrument people went, well, what can we do with one? And so they created basically an engine that takes modular level signals in and then poops them back out. Pretty cool. You can have triggers. You can have audio input to it, I think. It has a digital to analog converter. The digital to analog converter is a little bit more of a rare chip. I don't know why they chose this one, because that is a $10 to $15 chip. It's very frustrating. I built this one myself, and that hurt a lot because those are not flat. Ow. Anyway, I built this one myself, and I collected all the parts. And when we collect parts to build something, we always collect a lot of, you know, maybe a little bit extra. We always have a little bit extra, a couple extra parts, right? The problem is, wherever the parts were for this thing, I am stumped. Oh, is this that resistor that I was looking for? It might be. I don't know. I'll have to look later. I don't know where all the parts went. I had another one of these chips. I don't know where it is. So I put in a Mauser order yesterday. So that should probably get here by Thursday. So what we can do today is we can populate as much of this stuff as we can. I've already gone through the rigmarole of finding all of the correct resistors. And so now we need to do all of the other things as we move through. And we do this in the order of height. I have what's called a bill of materials, which is basically just a spreadsheet that tells me what R1 and C1 and L1 and L2 are, what that means, all those parts labels. So we're going to put this thing together and we're going to get it off to Julian so I don't have to think about it anymore, right? Hey, is there a Discord server? There is indeed. Hey, glad you asked, citizen. Why, you can just mosey on over to the Discord command and... There you go. We do indeed have a Discord, and it is moderately active. It's a fairly quiet Discord, but there's a lot of fun people in there. What the heck is that noise? Oh, it's the art equipment. Oh, okay. I was like, what the hell am I hearing? There's like a rush of air outside, and I'm like, is that a monsoon all of a sudden? Yeah, so I didn't mean to be completely incompetent with this project. I don't know why this thing kept kicking my ass. It was really just a couple little simple things that I could have done differently that would have made it work perfectly. But now we are going into Zen mode. I have dumped a couple parts over here, including an inductor. The Crimes and Ornamentation requires a couple things that I don't typically stock, and something that I probably should have used on that little spinny light is the larger LM1117. This is a different package and it's able to dissipate more heat. So this would be overall a little bit less toasty in its operation. I don't know where we got this one. I think we found this one in something else. I think this is on like an actual like usually professionally you see adjustable voltage regulators. You don't see bespoke fixed regulators like this, but I don't know, we found it on something, so I don't have one of those. I've ordered a couple of them, they're coming in the mail. The inductor here that goes here, L1, it's got a particular value, but I couldn't find one anywhere. You know, where are you going to find a coil like that? They're not that common. You see them in power supplies and analog stuff. The other Lone Star sent in this just eye-wateringly expensive Blackmagic SSD video and audio recorder. This thing sat in a rack in New York City at a science museum where it had a little squirrel cage fan sitting above it. Well, actually over here. Little squirrel cage fan that was puking air out. in order to keep everybody cool. That fan seized up. The grease in it got hot, dripped out, I don't know. Fan seizes up, no more cooling air. This thing baked itself to death. And so you sent it here. We were thinking I would try to repair it. Never got repaired. So this massive chunk of like a 6-layer circuit board I have sitting in my pile of just stuff. And it turns out in the analog section over here, we found a coil. It's fun lurking here while studying calculus. Hey, that's cool. I hope I am, I don't know, background music enough, wallpapery in my speech enough that you can absorb some stuff. I always had to study with people. That was what I learned in college. Oh man, I had this wonderful scholarship and everything, and it all got taken away because I didn't know how to study. I'm too lazy. So when I do actually want to learn stuff, I learn it with other people. That's the best way for me to do it. Yeah, a lot of college for me was learning how to learn. And then discovering that you were in the hardest math major in engineering at the time at that college, which is control systems. So L1 I found, and I don't think it's the right value, but I think it's good enough. I'm running the same exact part in mine. It's that part right there, the one that says 100. We've got one right here. It says 100. So let's get that in so I don't lose it. I'm going to put on maybe a slightly larger tip. Last week of high school, cramming everything, I didn't finish. Not fun. I had a friend of Julian and I, and he had to have his degree holder for high school, and there was no degree in there. I think he got it eventually, but it was kind of rough. I don't know why he finished like that. All right, so this was pretty roughly desoldered. I don't know which end's the top. Now, sometimes there will be a direction marking on the coil, just so you know which piece of the coil goes which way, but I don't think we have that here. I think this is literally just a coil around a ferrite core. I actually started out. There are just a lot of very unique noises going on outside. I don't know what the fuck is... There's gardening going on. Oh yeah, that's a wheelbarrow. But the window here actually opens up to like a deck area where there's a lot of plants. It's like a little alley between houses. 100 UH. This is supposed to be 10. Actually, I think it's 10 and then 0 zeros, which is a really lucky find. Of course, once we're done soldering this, I think what I'm going to do is throw it into the oven before I put any of the through-hole stuff on. And that way, everybody will be able to kind of organize their solder and align themselves. So that's that little goober. A little goober of an inductor in. I'm not going to concern myself too much with how much solder is on either side, just because I'd go crazy. D7. D7 is also a special thing. You don't see it a lot in modular synthesizers. Modular synthesizers use this 10-pin connector, 10-pin 2-row connector. The thing about the 10-pin 2-row connector is that you've got pairs of voltages, generally because they kind of assume that it's like a daisy chain thing, and you want to get enough of your power, and they don't really need all these connectors, but they use them. So they have positive 12 and negative 12, and then ground in between. The thing about an IE connector is that it's a square, and it does not have polarity to it. Although, to be fair, the most common IE connectors do actually have polarity to them. So you could put a shrouded connector in here, and then you could just jump this, and it would be fine. It helps, though, to have diodes on the input of your modular synthesizer, because musicians are not electrical engineers, and they will plug things in wrong all the time. So generally in an IE connector, you cannot plug it in off kilter. You need to have a plug that's this size or larger, and it won't plug in crooked, but it can plug in 180 degrees, turned around 180, because this is just, 0.1 inch spaced. When you do that, you're sending positive 12 into your negative 12 and negative 12 into your positive 12, and all the grounds are just where ground is. it's disastrous. I've had to replace many, many parts on these modular synthesizer units because my friends can't plug them in properly. So you put diodes on the input to protect everything. And if you have a full bridge rectifier, that means that you can not only have your diodes on the input, but you can have it so that positive or negative 12 doesn't matter. It'll always send it to the right place. Yeah, we know all about reversing connectors today. Ugh, I can't believe I did that. And I measured it right before I did it. So anyway, I was thinking, where am I going to find one of these things? One of these full bridge surface mount rectifiers. I took apart some plugs. Generally, in one of these little plug power supplies, you have a couple key components. You will have either through-hole or surface mount diodes, and they will typically be in a full bridge rectifier that can then gets, well, actually, it would go into a transformer first and then a full bridge rectifier. Then you have safety caps and stuff like that. So generally, I would expect to find a full bridge rectifier in a system like this. I don't really see it. I don't know what they're doing. They might be just using half of the phases and throwing it through these two diodes here. And then they would put it in a capacitor to smooth it out. And some kind of controller, transistors also running the show. So this, unfortunately, doesn't have what I'm looking for. I wasted a 5-volt transformer. Not that I would think I would really want to trust this thing. I don't see a lot of safety devices on it. Then I opened another one. Another one of these little 5-volt chargers. I think this one came with my insulin pump. Dun, dun, dun. There it is. I found it the second try. Pretty cool. So let's get this out of there. I'm going to need the big iron for this. Giving musicians a bare board is why this is a crime. They didn't give this. Julian bought it like this because he's a cheapskate. And I am too. Oh, there's a dead 1117. Hey, these guys really love their 1117s, huh? All right, this is a miniature precision machining vise. The reason I have this is because I got it from an estate sale, those are great. I should look for more, but it was probably meant to be used to actually do miniature precision stuff. I have had it on my desk and I've been getting my finger oils into it for like eons. So it is no longer, I would not count this as precision anymore. Man, those dogs sure love barking. All right, let's get this out of here. Open the doors, get them out of there. All right, give this a second to heat up. And then big iron. I'm using big iron because there's a lot of stuff here. Let's refresh the solder a little bit too. This will wake it up. Make it more solid. So the solder crystallizes after a lot of time, and this might be RoHS compliant, which means that it will have no lead in it. And so if we add a little bit of our rosin flux from the rosin core solder, as well as some of our alloy of solder, it'll solder a little nicer. It just kind of wakes up all the joints. Now what I'm going to try to do is bounce back and forth off my boy here and get it to just fall. It'll just fall off because there should be enough solder here that it remains molten for a significant amount of time. I've got to be careful that I'm talking with my adenoids. Oh yes, you see, the nerd voice is coming out. I need to un-nerd voice myself because I'm talking for 5 hours, but my natural tendency is to start talking like this or just start talking like this. That's not how I sound. Hey, yeah, that's not how I sound. Why are you fighting me? Are you glued? No way, this is one-sided. There's no way this is glued. Well, I guess I gotta force the issue a little bit here. So I'm gonna take tweezers and I'm just barely gonna touch them to the side here. Just give them a little push. Come on, give me the component. Don't tell me this is doing something cursed, like having a piece that goes in. Oh, no, there it goes. Okay. How much did I ruin the pads? Oh, I lifted... No, I didn't lift the pad. Yeah, pads are still down. A little bit of flux probably would have helped. Okay, so there's that. Get this out. And I need to make sure that I put the new one in the right way. There are markings on this, presumably, right? Actually, let me, they're cheaping out using a 12-volt transformer to power a 5-volt USB brick by using half the voltage curve. They do that. Yeah, that's because you don't need as many components. And when it's down to a game of how many components in order to make this thing have this such and such margin for profit, I'm just trying to clean up the pins so they go in nice. Oh yeah, I can measure it, but there's probably markings that'll tell me what it's doing. Ow, that whole thing is hot. This is where that piece of circuit board actually comes in handy. Hold on. The vise is sucking away all my heat and simultaneously burning me. Copper's money, less windings. Good call. All right. Yeah, the spinny light, I should have had it working so much faster than we did. It was just like the perfect storm of errors. Ow, ooh, that gets hot fast. I finally just got my shit together and did it piecemeal. It all worked, but that was a project that I should have been able to just do, right? I still use lead-based solder because I know how to set the temp on my iron. I should buy more while there's still some around. Yeah, I mean, I'm using partially leaded. Okay, so there are markings on this. It's just, it's very difficult to see with the lighting. What I can do is I can take my pen light here and I can show you that there are markings on this. They're just not very good. Here, where's... Oh, it's too bright. As I detonate my light, you guys all go blind. It's usually like an angle of light kind of thing. Well, I do not see the markings that I should. Hold on, let's try tilting it around. Ugh. Is that a plus that I see? Yeah, there's a plus over there. So I think it's plus and minus on it. VB10F. Let's look up VB10F. VB10F. Ah, there it is. Full bridge rectifier. Glass passivated bridge rectifier. What does that even... All right, so our pins are there, and we've got the plus and the minus there. Let's brighten that up a little bit. So the plus and the minus go to the left side. Got all these boards sitting in front of me, man. Sir, can I just please see the markings? Sir, I need to see the markings. I need to see anything. Okay, yeah, there's the plus and the minus. So that's the direction that it should be in. So we grab and we slide. We do the shimmy slide. Oh, wait. Different iron tip because we are now in, we're not pulling this stuff out of stuff anymore. We're now putting stuff into stuff and things. There we go. Let's get a little bit of solder. Why do I always say that weird? It's because people always try to bother you saying that wrong. I'm like, no, you're just terminally British. All right, so anchor pin. We're out of focus. It's out of focus. It's not bright enough. That shake is so bad. It's so bad. Why is the shake so bad? Probably because the camera's like high frame rate. We're actually getting 60 FPS or something. So we get to see all the good and all the bad in this world. Oops, okay, pushed down too hard. I usually push down on the chip just to seat it. Probably don't need to do that. But sometimes I get problems where, because I don't have parallax, you know, I don't have two eyes looking at this. It's just mono eye. That's different. That's when you get mono. Okay, good enough. So there's a clever way to have it so that your musician can plug in the power thing in either direction. It doesn't matter what direction they plug it in, because the full bridge rectifier is not only going to provide reverse protection at the same time, it's also going to route your power in the direction that it should be going. So bada bing. Okay, can we, hello, excuse me. There we go. It's got big legs, so this should be soldering easily. It's just my positioning is weird. But again, this is why you go by height. You do the lowest things first and then move your way up. Now that's a 3-volt regulator right there that I don't have. And the last time we did one of these, I had a board that had a blown up microcontroller. I think it was one of the ESP boards. And so I was able to steal the micro from it. Do I have anything that is so obsolete and also has a voltage regulator like that on it? I don't think so. I don't think I do. This thing's super modern. Well, the two battery regulators that I threw out recently probably did have one of those on there. Oh well. Yeah, I might have gotten it from a board like this. Well, that's a 6-pin. What is this even? Oh, this is a touch button. Never mind. Never mind. Yeah, some of these are too old. Like the Arduinos are pretty old. And that has a 6-pin regulator on it. The Atmega 328s, I don't think I'm ever going to do anything with. But I also kind of don't want to throw that out. I still use lead-based solder. Oh, yeah, it's a message from 20 minutes ago because my chat is vibrant. Look at all these people chatting. Whoa. Okay, anyway. Oh my God. What are you? Hello. Copyright 2005. I might want to keep this one just because it's a relic. This has really been in my possession since 2005. It might have been the first thing that I ever ordered from Pololu. I think it's a servo controller board. That would be what I'd want to steal and transfer over. I actually, there are voltage regulators coming in the mail, so I'm not going to use this. But I'm certainly not doing anything with it since 2005. Oh my God. Let's put you back in bed, Grandpa. All right, let's move on to other stuff then. I have other things to solder. What's still missing here? I don't know if we're doing anything with the reset. And then component-wise, I think I got all of my resistors down. We got all the capacitors down, except for these big ones. So all that's really left is these guys, the transistors and one very special negative 10 volt reference supply, which, hold on, I put them all together. They're over here. Problem is, well, the problem is I put them all together. Wait, where are they? This is the wrong bin. Wrong bins. Hold on, I got the right bins. The correct bins. Nope, that's not it. Nope. And that is not the thingy-wingy. Oh, did I just ruin this bin? I think I overbent that little clip there. Ugh. Okay, different bin. These are surface mount storage bins. That's all they're called. And you got to look on like Alibaba for them or whatever. They say Wen Tai on them, but I don't know if you can search Wen Tai. But they're very useful because they can interlock with each other, and you can put together, for instance, what I could have done when building this, and probably what I should have done, is to put each component type that I needed from the bill of materials into the bins, and then it would be as easy as just going to the next component and placing it on the board. It helps to organize that quite a bit. I, however, dumped everything into one bin, thinking that was smart. And so now I've got a bunch of weird stuff. Put that down on the desk, and now we got to sort through that stuff to see what works. There's a 3D printed clone of these, but there's no clear lid. I see. Do they interlock like those do? Because that's the useful part, is when they interlock with each other. 1P, that's a 3904 equivalent. "1P, please." Actually, it should be 1A. What is 1P? Put that over here. They all came from the same bin, so they should all say 1A. 1A, or this is the negative 10 supply. This has got much more comprehensive lasered engravings on it. See, that says 1A. You guys might not be able to see it, but we've gotten kind of adept at this. Let me move closer just so that you guys... Oh, there it is. I've got to restart Stream Deck now. All I had to do was move it a little bit. Oh, they might not work interchangeably, but they are the same. Yeah. Hold on one sec. We got to get the microscope working again. This microscope is an amount like a Frankenstein's monster of various components. It's a Logitech C920, but it's in this aluminum case, which is awesome. But then it's got a USB micro on it, which is terrible. And I've tried to hot glue this so that it wouldn't move, but it just didn't work. It didn't really take right. And so this is like a little bit loose, and it's kind of crazy. And so when I move the camera around, this will disconnect. When this disconnects, my Stream Deck will no longer see that camera and be able to use its tools to edit the settings in it. So when we reconnect to this camera, what's going to happen is I'm going to deactivate it and then reactivate it. Okay, it's not reactivating. So we're going to deactivate it, unplug it, give it a couple seconds. I really need to do something about this. I was going to make this a USB-C, but then my milling machine broke. There we go. Okay, so now it's back, but the camera is not primed. And so what I need to do is I need to go to Stream Deck, and I need to go... Oh, I actually need to go to the tray icon. Thank you, Stream Deck. Quit Stream Deck. What I need to do is run an INI file that'll close and reopen Stream Deck. And I can get Stream Deck to run the INI, and then it'll do those tasks. So that I can have a button that'll just restart it. All right, starting up Stream Deck. I'm going to give that a second to boot up. Come on, buddy. All right, and then we're going to go set up. Wait, why aren't those are, huh? Oh, good. It's not connected to OBS. What the fuck? All right, let's try again. Start it up again. Oh, because it updated. I need to update OBS. Heh. Well, we can't do that right now. I'll just lose a little bit of production stuff. I won't be able to do my comedy zoom in, unfortunately. Oh, that actually, maybe that did come up. No, because I can't switch to my face cam. Why not? No. Oh, there we go. Then it all came up. Weird. I guess it took a minute to do its little connection. I love that button. This is my favorite button. Okay, okay, that means that I can go to this, and then I can do the micro calibration, and we're back. Okay, so let's get nice and close to these. I realize that some of you are watching on your phone, which is crazy to me, and you might not be able to really see what I'm doing. I'm looking at the markings that are lasered onto these things. The FZEX, those often, like especially with these types of surface mount components, these will not correlate directly to a part number, which is really frustrating in surface mount electronics. Generally, that's because the technology at the time dictated that they can't laser like a full part number in, but I think that's kind of dumb and lazy. They could have given us the beginning of a part number or something of that nature. They I don't know, it's annoying. There's a whole PDF that's huge that has all of these markings written down, and you'll get one marking for multiple different surface mount components, and you can kind of infer what your particular component would be. But generally, 1A is your 3904 equivalent transistor. And so I have a whole bin filled with 1As, and I got them all together, but then suddenly we have 1P, and I don't know what that's all about. So I'm gonna put that one aside. We'll have to go find another one of the 1As. That's easy enough. 1A, okay. So these are 2N3904 equivalent jelly bean transistors, and this one is a -10 voltage reference. The -10 voltage reference is because when you put a voltage into your op amp and you apply a -10 reference to that, it will bump the voltage level to a point where you can then send it to a microcontroller. It basically makes it possible to have a 3-volt microcontroller speaking to your 10-volt system. I had to dig really deep to find the storage boxes in my print history, but you found them. Oh, there's a link to them. Let's take a look. So if anybody's looking to cheapen out on these already cheap bins, that's cute. Yeah, you don't have the lid, but they still lock together within their own ecosystem, which is pretty cool. Oh, look at that. Those labels are that's pretty slick. Look at this. Because I'm living the way that I am subject to having to watch the nightly news a lot, or it's just on, and I've noticed they're starting to use language like, look at this, check this, look at this. They're trying to get people off of their phones and watching the TV. It's pretty funny to hear them work it in, because you typically wouldn't have like a newscaster go, look at this person did. Those are slick. That's really slick. So the link for that is in the chat. I can see the 3 legs just fine, but the echo from my headphones and the phone audio, yeah. I like the 3D printed multicolor labels. Yeah, listen, if you're not going to do the 3D printing route, get a label maker, the little brother label maker. I want to get the new one. It's a little too pricey for me to just go and buy it. I have 2 of these big yellow brother label makers, the thermal labels, because if you just try to write on top of the box with like a Sharpie, that won't take. And if you rub it, it'll rub off eventually. And even if you don't rub up against it, it'll like fade away. I just use a label maker despite having, yeah, printing available. The other thing that it's really good to do in these parts boxes that I haven't kept up with is when you put a part in, if there's room around the part, cut out the Mauser or DigiKey label and just stuff that in so that when you run out, you know what part number to look up to order it again. The old school impression labels. I mean, look, if you want to go for a look and you want one of those big squishy things in order to make your labels, but the thermal labels allow you to put a little bit more information on each one, like size. So that's what I use them for. I could have gone for 3 lines on this too. That would have been a good one. Yeah, it's like a plastic that deforms and brightens up. Yeah. Okay, so where am I putting this stuff? We have a bill of rights, I mean materials that we need to follow. And so down here we have all of our Q's and R's and whatnots identified. So where are they going? MMBT 3904, 1, 2, 3, and 4. So we'll put a 1A over here. I just double check on mine. Mine says 1A on it. One AM. 1 AM. Okay, I'm gonna double check. I'm gonna double check with the transistors that I have and make sure that I'm putting in the right thing, because last thing I want is for Julian's synthesizer to explode almost immediately. We seem to have a track record of having that happen here, so which I don't like to have. 3904 SOT23 NPN. One A. Okay. Same thing. The M must be some kind of a, I don't know, tracking or slight difference. I don't know. One of those things. One of those weird things that you run into in electronics. All right, so there's this, and this is going in Q1. Where's Q1? Q1 was, oh, you wait right there. Grab you. All right, let's get an anchor pin going. Yeah, the SMD codes was one of the biggest like failures of this new technology, surface mount technology, and I really wish they would reverse a little bit of it, because they did exactly the right thing with the resistors, where your resistors literally just tell you what they are. They just have a number on them that is the value of the resistor. But these transistors and stuff, we really could have used some help. And at the time, I guess they didn't have the technology, but now we could write a whole goddamn novel with a laser on this thing. So I don't know why we're not better labeling our surface mount components. The fun one for me is actually the symbol for the transistor looks like a transistor with its pin in particular locations. And the old school transistors were laid out kind of like the symbol for the transistor, but on the surface mount ones, they decided to have the 2 sides of the transistor over here. They kind of made it off by 1 pin. And it's very confusing, very confusing. I guess they did it just so that you could have your pull up or pull down resistor on one side. So your source would be here, your drain, and then your gate. So you would have your gate to source resistor just sitting parallel to those pins. Japan used to color code transistors? Huh, for NPN and PNP, I did not know that. The worst part about this is that the resistors that you can usually measure in circuit, but the other stuff you can't. Yeah, that is actually pretty, isn't it ironic? Don't you think? Kind of like a rain on your wedding day. None of that's ironical, Anis. I'm sorry. All right, Q2. Right there. And then the Q2 that I brought over. Where are we? There we are. Man, some of these are sloppy. I was working quickly when I was soldering these in, and this thing will go in the oven at least once to realign everybody. Excuse me, solder. Visual asthma soldering stream. Why? I guess because it's a ground pin, it's like sucking all my heat away. It really shouldn't be doing it that much. It really shouldn't be doing it that much. Man, I gotta work on my voice, guys. I gotta work on my voice. I'm sounding way too nerdy as I talk to you guys. Hey, it's me, oh bother. Welcome to my stream. Stop smushing my head in that toilet. Hello, it's me, oh bother. No, that's stupid. Ugh. Okay. Nope. Crooked. It's all kinds of crooked. I have to do the very best. We will not allow for any inconsistencies. The chip that I brought over from the other bins is definitely not useful. It's like an SS16. Not used in this design anywhere. I don't know what I was thinking. What the? Give me that. These capacitors are going to be a nightmare to solder as well. It's actually best if we go in from the side for this. Okay, why is that? Okay, there we go. So heat up the side. Hopefully we heat up the pad too. And just give it a little bit. And let that kind of blop down onto the pad. This one I've got a little pad sticking out so I can go right here. And then that will solder to the pad. No, never mind. It'll not do anything. Okay. Just like that. Pressure is a little bit down, but mostly that's just the weight of the iron. It comes in like that, and then we cover everybody in solder. Bada bing. And of course my wrists are flat on the table. That's what's stabilizing my hands and keeping me from shaking all over the place. Some people are very shaky, like too shaky to do this stuff, and I don't think there's too many people that are too shaky to do this kind of work. You know, a little bit of shaking you can mitigate by positioning yourself properly. That's another 1A. 1A is generally the 3904 equivalent transistor. That's what they normally label those. There's dog hair. There's dog hair everywhere. I'm sorry, everybody. I have a type of corgi that sheds a lot. She's what's called a fluffy corgi. They have long hair, and they're wonderful dogs. They're very smart. And we love her to death. Certainly my favorite dog that I own right now. She's been great. She's gotten me outside, which is pretty important. Get back on my shit so that I can lose some weight. Look like a normal human being instead of a giant beach ball. That'd be nice. Diets are very difficult with diabetes because you'll go hypoglycemic, and then it's like, well, now I got to drink orange juice at it. Okay, there we go. Get a little quiet there as I hold my breath, try not to shake completely on camera. I had very steady hands. I think I'll probably get them back with a little bit of weight loss and muscle. I got to build up a little muscle. Muscle helps stabilize. The big muscly hands are actually quite steady. Actually, my hands have been very steady today. I've lucked out. All right, so that was Q3 and now Q4, which who the hell knows where it is? Is that this one right there? That's U6. That's our 10 volt regulator. Maybe we should put that in before I screw up and put it somewhere else. Where is that? LM4040, EM3. Wait a sec, 5.0. Good thing I didn't put it in. 1 minute. I would have blown it up. That would have been a disaster. I'm just searching for this part. Those are all op amps. 400-volt triac. 4148. A Pafet. No, okay. Nope, not that one. LM4040, 5 volt, 2.5 volt. Is this on the 5 volt or the 2 and or the I don't know if I got the negative 10 one out or I did the 5 volt one. Apparently they're using the less common 5 volt one. The 10 volt one, the negative 10 volt one is really good for doing this kind of stuff. Okay, negative 10. I'm going to take out a negative 10. We'll see if the part numbers match up. RDA, what? Okay, RDA is apparently that. So then if I go over here and I do LM4040 10 volt. Oh, they're in their own, they're 5 volt rather. They're in their own thing. Oh, and they say FC2EX. Okay, so I did get the right one. I got the right one. I can trust past me to do things. Yeah, I've got a couple of these weird references. Use them in a lot of test equipment, which I should follow up on the PCB design for my module testing module. I've got a nice vacuum fluorescent display that I'm using on it. It should be really cool. But right now I have it set up on one of those little OLED screens. So, okay, before I forget, I'm putting in U6, which is this thing. Oh, the weed whackers are here. It sounds like a drone show outside. Lots of buzzing. All right, this is my last transistor. I gotta put this one over somewhere too. Put it down there. Okay, let's get this one soldered. So yeah, I mean, these are the techniques for doing surface mount soldering. If you want to cheap out on modular synthesizer equipment, and you're good at doing this kind of stuff like soldering and, well, programming microcontrollers a lot of the time, the mutable instruments designs are like, those are the building blocks that you can use to make your own synthesizer equipment and have it be legendary, because all of those designs, she really refined. Like, there's really quite amazing sort of minimalistic microcontroller designed, modular instrument voltage level microcontroller designs and op amp circuits and stuff like that. I don't particularly love the STM32, but Emily was particularly fond of it, I guess, because of back, 10 years ago, 5 years ago, that had a brilliant amount of computing power, and so you could really get those waveforms to be refined. But I have used the building blocks of those designs in my own setups, and so some of that includes having the negative 10 volt reference that will then convert your input when it gets inverted, and it becomes maximum 3.3 volts just due to the math. It's pretty crazy. Trusting past you, that sounds dangerous. It is actually quite. I mean, trusting me, even present me, has led to things blowing up today. You guys didn't get that wonderful heart-dropping moment where you hear a little snap and you smell the electronic smoke getting released. I mean, you saw it visually. It's just the bouquet of smells was very familiar to me and very disappointing to me. I think I'm going to leave it in like that because when we do the oven thing, it will realign itself, I hope. Of course, the oven's probably full of dog hair too, so when I fire that thing up, maybe I'll use the hot plate? I don't know. The hot plate is a giant liability, though. It's just this big open air, superheated thing for me to put my arm on and lose all my skin. So that what's going to happen when I put this in the oven for kind of its final like baking and final parts alignment is that the 3 pins are all going to have molten metal on it, pulling it in the same way. If one of the pins on, for instance, like a resistor isn't soldered, it will actually do what's called tombstoning, where because this solder is kind of pulling on the entire surface area, it's got more grip on the side and on the top of this chip, and it will actually make it lift up vertically. That's right. The magic smoke pump, the Lucas Electric magic smoke refill. Hey, I didn't buy 100 LM1117s for nothing. I have those in a bin now, so I'll be able to fix up that little power supply board and put it in the second spinny light. I only have enough parts for the one spinny light because we blew up my only other ESP. I've got 10 of those coming in the mail. I'm really lucky we were able to actually finish a project today. I'm happy to have it now. My only gripe is that it's a little warm. I think maybe I'll put the voltage regulator in the middle of this thing so it doesn't like heat up one side. I don't know what I'll mount it with though. Can't use hot glue, the whole thing gets too hot. That's kind of crazy how warm that regulator gets. All it's doing is powering up an ESP, and that thing doesn't have that much heat to it. My iron's off. It turned itself off. It thought I was soldering in bed and fell asleep. What part of the ESP did you blow up, though? I heard a snapping noise. It made a snapping noise. So unless I put it in the oven and get the can off of it, because that would be the way to get the can off. You could also use Chip Quick if you're lucky, and a big soldering iron tip, and then you go around the perimeter of the can heating it up and it'll eventually pop off. The best way to do it is just to preheat it in the oven and then you pluck it off before it cools enough. Because that thing, those RF cans are soldered, damn it, those RF cans are soldered all the way around. And on the ESP, it's not worth it for a $1 chip to get in there and diagnose exactly what happened. What happened was I put 12 volts into the ESP. That's all you need to know. And it will never be the same. It's crooked. Put it in my CD and then let it run. It really helps to look cool if you just stumble over the thing that you were saying, especially if you were singing like Will Smith lyrics. That's really cool to do. You're starting at a place of nerdiness and then you're messing it up. Everybody loves to listen to that. Put in my CD and let it run a rhyme. I said that because I was thinking about what I would be doing normally when I'm soldering a circuit like this, and I would probably have either music going or like a stream. I would be watching somebody stream while soldering things like this. You can kind of turn your brain off as long as you're not messing up. That's why good headphones. If you're gonna work as a technician soldering stuff, get like nice headphones that fit you well. And then hopefully people will do proper headphone etiquette, because when I was writing reports, I would have people come up to my desk way too often and try to say stuff to me while I had headphones in. It's like, come on, man. Try to work with me here. Might have you playing in a tablet, I might not. Depends on whether or not I have a friend over to help me drink my beers. Oh, there you go. Good to know. Okay, so that's all of the components, except for the stuff that I don't have. Oh, and the capacitors. We need to do these big capacitors. These are very annoying. These are very annoying. Did you see my... Oh, no, I didn't. Oh, I don't know if I'll be watching on Saturday, but I know I'll be miserable trying to reassemble a 280ZX that had its transmission out of the car since 2003. Man, what a good car. What a nice car. I love that car. I would love to have an old Datsun. It would get square, well, not square, but it would get new, like, external fenders faster than you could even calculate because it looks so good with fenders. Yeah, that's fun. Look, my car has been sitting, and it bothers me quite a bit that my car has just been kind of sitting. I did the battery tender to it, I think 2 days ago. I was going to drive it, but it turns out because of the PGA Tour, between mine and my friend's house, there was every officer on the force, and my car has lapsed not only in its inspection, but its registration, and so I need to register it as an antique because I just don't use it that much. All right, big capacitors. What are we looking at? U, C7 and C24. So these are 50 volts. They're asking for 25. As long as they're similar to the form factor and they fit, they'll be okay as long as we are over the rated voltage. Under the rated voltage is when you get the viral clip of me with the capacitor blowing up and I go, fuck! You don't want that. You don't want any of that. This is maybe not the right choice for the anchor pin. Yeah, hold on, I gotta desolder braid that. Meanwhile, my fingers are trying to like fold. Glucose levels sort of fixing. It's sort of going back to normal, but that means I get lactic acid buildup and then I get cramps. And those cramps can sometimes be Charlie horse adjacent. All right, so we're gonna anchor it to this one instead of this one that has all the heat sinking going on. Actually, they're both miserable to solder to because one's a giant ground plane and the others. These capacitors in general are miserable. Oh yeah, and if you get it wrong, there's a very small gap between these two. Just to make it a little spicy, and usually very little of that pin actually sticks out. It needs to be backed all the way up to the edge. Well, good as it'll get, I suppose. That looks really gross and sloppy. Ugh. I've been toying around with this prototype for a MIDI to CV audio mixer, okay? On one module where every port is MIDI configurable, would this be something others would find useful? I don't know. I haven't gotten quite to the point where I'm even playing my modular synthesizer. I have been assembling stuff and fixing stuff for friends, so I need to like sit down and figure out what I like in the modular synthesizer. I want to get the MC505 running though, because that thing can also do MIDI, but I think mostly having all of those extra parts will help me out, and then I can concentrate on making funky noises with the synth. Oh, these are just, I hate these things, man. Please let go. Where's all my heat? I need the big iron tip on this. I need a definitively large amount of solder heat. Going over the voltage is a choice because of ESR. Huh. Well, I'm just saying with the capacitor, if you're designing a system with a cap, you want the capacitor to be over the voltage of what you have, because the opposite, if you go the opposite way, that ends up steaming your electrolytic solution inside of the cap and turning it into a tiny detonator, which will blow up in your face, and then you make a funny noise and chat laughs and clips it, and then the clip goes viral, the only time you've ever gone viral during a mistake. See, they don't, there are solder-friendly pads that you can use for these capacitors. These are not solder-friendly pads. It almost makes sense for me to go in here with hot air and do it that way. Yeah, if you get solder-friendly pads, then the pad will stick out a little bit and it'll help you get the iron on it. but they're literally just regular capacitors that are maybe slightly smaller than what they would normally be, and then they have little bent legs with a plastic thing on the bottom. It's very, very annoying. Yeah, I got to think about that idea because I don't know what that entails. All the MIDI to CV stuff. I have a singular channel MIDI to CV module, but I don't know in terms of like sequencing what people are doing. Ah, the can is very hot. That's nice. That's very nice. I love it. I love burning my fingers. I guess I just have to rely on the oven to fix whatever weirdnesses I've put into these two. There's like a slash mark on that. If it's just the power supply, then it's fine. But filter caps, yeah, filter caps get weird. And I could sit here and I could measure the caps and make sure that they're all like exactly what's supposed to go in the system. But I'm not going through that much trouble. I'm just not. I'm just not doing it. Ugh, this tip is gross. All right. Now these are what value? These are the other two. I thought I had 4 caps over here. No, it doesn't look like I do. Yeah, these I have to cram. Oh, these here, there. Those are both 10s, right? Oh, thank God. I messed up and put one of these 22s in there because these are 22U, but I didn't have 25 volt ones. I had 50 volt. I had 50 volt and then like 17. 17 was a little, I mean, I guess it would work, but basically it would be like a multiplexer for MIDI, CV, or audio where the ports can be configured via MIDI to become whatever I want. MIDI in or out, CV, audio in. The hovercrafts are here. You guys may hear some buzzing. I don't think my voice is going to come through as clearly as before because, yeah, they've descended upon us. The alleyway is filled with lawnmowers mowing the little tuft of grass that we have back there. It's going to be a little loud. Hopefully they won't get too close, but the dog's barking and the lawnmower's going everywhere. What did I use? Oh, I used 25 volt. These are 50s, but they're a little big. Yeah, that's just a little bit big. Let's see if we can find, let me see if I can find the right thing. If I found those, I'm likely to be able to find the right ones. I had these little kit bins of multiple values. That's 100. 47, so 22 would be these. These I don't think are the right voltage. Did they bring Rudy Giuliani? No, but he was responsible for scheduling it. So, because if you guys don't know what they're referencing there, is that we actually do have Four Seasons Total Landscaping. That is the company from the famous political gaffe. And they're the ones that mow our lawns. It's pretty fun. 220, 16 volts. 125. Audio ports can be. Yeah, I don't know how MIDI configuration like that works, and Julian told me, don't worry about MIDI. So he said, don't worry about MIDI, don't mess with it. I'm like, oh, okay. Yeah, that was, I love how quickly the furries made the map for Four Seasons. For whatever that is, oh, why is that? The VR sexting game, whatever that is. VR chat. That was it. VR chat. That's what I was looking for. 22, 50 volts. These are the ones that I already have. I don't know where I would have gotten those other 22s. I probably hunted around for them. Let's see if we can find them in something else and take them out of there. This thing does not use that type of cap. That thing's too old. What else do I have that uses that type of cap? This is like the technological level of your average maker for these modular synthesizer things. So you'll see a particular type of technology like these capacitors being used on it, whereas all of my spare parts stuff exists in different eras of technology, and so you see far less use of things like, you know, this particular type of capacitor. This is a GeForce 4 220. No, that's a 330. Not quite my tempo. My GeForce 4. I don't know how much other stuff I have that actually uses that capacitor type. Power supply boards generally don't. This stuff is too old. Let's see, anybody else in here? Oh, what are these? Ah, old 3D printer driver. 100. 220, 16 volts, but I've only got one. Ah, you sons of bitches. Why would you only have one? Oh, that's disappointing. Oh, I probably stole them from down here. Darn it. Is that an LM1117? Wait a minute. What kind of GeForce 4? The kind I cut the end of the card off of so that I could... No, it's not an 1117. This has some weirdo voltage regulator on it. Yeah, I'm not sure which GeForce 4 it is. But it's my old one. Darn, nothing useful here. Wait, what was this stuff? 330. See, that one is useful if we can find another 220 16 volt. How many volts are these ones that they suggest? Oh, they don't tell. 35 and 25, so I can't use 16 volt, no. Because it's a 12 volt device, it probably... That's a weird regulator. Okay, nope, not useful. Here, look at the graphics card again. A lot of crazy stuff on this board, actually. There's a lot of coils and stuff that... Oh, what's that one? Hold on. MX440. Hold on, let's... Trying to be a good noodle and get some tasks done. Calling VR chat free sex game is pretty accurate. Yeah, I mean, you know, no pretenses here. Yeah, I don't get... this stuff is not coming off. I need to get like a guitar pick on it. Maybe you can infer. CG A3 4600 at the bottom. That's the top end card. It's worth fixing. It's been severed. I cut the end off of it. Actually, this thing is dead. That's why it's here. This thing was not end of lifed because it went quietly into the night. This is not an active card. This is something that my friend and I blew up. We pushed this thing to the edge and then it jumped off. It had a warrior's death. There's some cool stuff on here though. Don't know what that is. Don't know what that is, but it's cool. There's super duper tiny ones of these guys. Looks like I've stolen a couple things from this already. Unfortunately, all the capacitors and stuff are way too big. I wonder if this has a coil that I could use though. I think that's just a diode. Yeah, that's just a diode. Lots of powery stuff going on. Oh, that one blew up. The end is just power connection. No, 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 no. This one didn't have any power connection on the end. See, this had this here. And then I cut it off because I needed a piece of FR4 to work on. This card, no pretenses, this card was dead. We killed it. We got him. Why was it so long? Because this is actually the form factor of your PCIe slot. Your average PCIe slot is the entire length of the computer, and then there should be a plastic thing at the front that catches the card in the front so that it's stable on both sides. But then they decided, because the cards were only going to the connector and a little bit beyond, that they didn't need that stability element. And so as card coolers got larger and larger and larger in the latter half of this century, they became heavier and heavier, and they really were, under specification, supposed to have something that would support the front of the card. So the back of the card would lock in, the front of the card would lock in, all that weight would be supported. But instead, now we have armored PCI, we have armored slots. They put metal around the slot to keep the card from bending it down and out. And now you have like action figures posted at the end to hold up the cards. But it was the original specification was that the card was this entire length and it would be supported on both ends. Yeah, it would be extremely useful now. It would be very, very useful this day and age where we're putting all this copper cooler on the ends of our cards. I forget what these things were. They were like power supply related. SC1 something or other. Yeah, this is the GeForce existed in the area of technology that we like to exist in, where you can actually look at stuff and say, oh, look, that does that, instead of it all being like a billion layers and this size. This size is kind of annoying. Can still kind of work with it though. All right, there's nothing useful in the GeForce. I just wanted to look at it for a bit. Yeah, crazy, crazy stuff. It even has the ADC power and video connector. There's no, why does everybody keep talking about a power connector? There's no, this is before the day you would have external power going into your graphics card. This is predating that. Rated 28 volt DC, 4 amp max. Unless one of these is the power input and I just don't have the connector anymore. This is an AGP card and it has power in the slot. Yeah, it's all in through that. Old school. What era? Do we have a date on it anywhere? What is the date? Made in the USA. Well, that's pretty cool. 2008, maybe? 420? 6.7? I don't know. The rough edge DVI connector is Apple proprietary. Oh, this funky guy with the little locking clamps on it. Crazy. It's kind of cool. All right, putting it away. Carries power for a CRT, USB, and DVI. Weird. Oh, Sony camera. Do you use? Sony camera uses weird stuff. These are all very weird. This is like it's like alien technology. Because nothing is like labels. This is like early surface mount stuff. And the design is like weird. It's Can you imagine designing something like this? Look at that. It's so weird. We have taken parts from this thing before, but you know, typically the parts are a little bit harder to kind of identify. This tiny little crystal over there. Just weird and different. And that's 4.7, so it's not us. That ain't us. That one says 100. I wonder if that's a coil. That might be a 10 Henry coil. We might have been able to use that on the Julian synth. We're not looking for that right now. We're looking for those little tiny capacitors of a particular value. Nope, not on you either. I don't know if I'll really be able to dig up any. What do you use? You don't really have capacitors. Nope. Nothing useful. I don't really think I'll be able to find something. I just wanted to kind of peruse all of my electronics collection to see if I could happen across the right thing. Now this one is a beast. This is a 7-channel sound card, USB thing, and it's got all these op amps and this Creative Labs chip over here. Little volume, pushing the jig thingy. Hey, what's up, Almost an Engineer? How you doing? But these capacitors are this type of like tantalum surface mount thing. Not useful, unfortunately. I haven't found any use for all the wonderful components that are on this thing. Darn. Okay, I don't think I'm going to be able to find... I don't... That's what you sound like, streamer. That's what you sound like. Okay, so I don't think I'm really going to be able to find equivalent capacitors like that, but I do have a collection of caps. So let's see if I can just source... Well, the ones that I have out are the only ones that I think will work in this. I don't know what they're doing in the circuit. Creative USB DACs are very nice for the price. I had a 7-channel one that was running my big 7-channel speakers, and it was nice to just have something I could plug headphones into, and it would shut the speakers up. But yeah, it was a lot for that little tiny thing. Kind of cool though. Nice having one big volume knob for everybody. And then I went to the shit audio stuff that does basically the same thing, only it's supposed to be for, you know, whatever, audiophile light. Not quite audiophile. You don't want to identify as audiophile, because then you get jumped. They'll fucking stab you in an alleyway. You think you're one of us, huh? Your cable's leaking. I think that's the entirety of my capacitor collection in this size. So maybe you should get one more of these kits. An audio nerd will tell you they're junk, but they're cheap. I haven't messed with any of their newer stuff, but I mean, apparently that DAC was pretty nice for what it was. That was pretty nice for what it was. So the only 22 UFs I have are the 50 volt ones that are a little bit big for the purpose. What is it doing though? Let's take a look in the circuit and see what it's doing. Yeah, because man, they got the right ones. UO_C schematic. This is jack plug, so I don't really know if that's... it's also very hard to look at. Tall Dog Electronics. Thanks. 8 HP Ornament and Crime, page 11 of Mod Wiggler. I don't want to click on that. That seems to be the only like PDF, at least that we can find immediately. That's just an image. It's just a PNG of the PDF. I would like the PDF because I do not like Blurrovision. Yes, I can totally see what's going on here. 22U, and that's just on the main supply. Or are they... Well, what specifically, what's the numbers of these? 1 and 2. And they're coming from... Oh, yeah, they are coming from power. So C1 and 2 are our initial power filtering and stability. and those are 22 UF, but they don't have to be. I can put other values in there and the performance of the unit will still be fine. So we are going to sub something in. Basically whatever looks like it's the right size. I mean, 47, oh, I only have one. Why do I only have 147? What is this, a sick joke? Am I just a joke? Is that what's going on? There must be another thing of capacitors. Surely there was another. 47 at 35 volts would be just fine. Just get the closest larger value you have. I mean, smaller wouldn't be a bad thing, but this is larger and it's the right size, I think. That actually might not be. And then the next one I have is this tiny thing. Well, it got smaller. Why did it get smaller? What's going on here? $147 and a 10. No. The 47s would have been fine too. I mean, this is just like the main input power stability. That's all these are doing. Actually, 22 at 25 volts. Wait a sec, that's the exact right capacitor. And it's 24 volts across both of these. So it's cutting it a little close. I don't like it being in that voltage, but it'll do. Wait, is this a different one? 10, 16. Wait, what is the 20? What did, where did that come from? It's like the exact capacitor that I'd need, except I'd be more comfortable with it in 35 volts, just in case something shorts out. But where did the 22? Oh, I guess this is mixed bin. That's weird. Okay, this'll do. Oh God, I lost it. I lost it forever. I think that's one of them. 10. Ugh, get it out of here. Where did it go? I just had it. Oh my God. This is it? Yeah. You'll come with me. Whoa, shaky thumb. Bonk. Okay. 222s are about 147. Just add a tiny one next to that. This is fine. This is fine. This is the 220 rather. Or no, 22 UF. This is 25 volts, not 35. There's a chance that a sunspot could make it a little bit less comfortable in its position. I would appreciate a 35 volt there. I have one 35 volt 47, which would do great in this job, but I only have one, and the hundreds are too big. So, I don't know what to say. That one is 16 volts, so that's outright. We can't use that. And these don't have caps. There's no caps. There's no caps here. That goes in the bin. Where did the other circuit go? All right, we're just going to use those. And hopefully they're never pressed beyond their limits. They're running at about half voltage typically, but it's possible under crazy circumstances they might actually see more than 12 volts because the overall voltage in the system is 24 from negative to positive 12 volts. But I do not think that's going to be an issue, so we'll put these in. Famous last words are what they are. It's possible something goes wrong, horribly, substantially wrong. Why? Like it's partially soldering itself in. Okay, there. And that leaves me just a little bit of room to position it, but that whole entire thing has already soldered itself down. These caps are just notorious. They're easiest when you're using hot air, and when you put hot air on them, they will just, put themselves into position just fine. But it requires a hot iron, and you've got very little pad to work with if you're putting, a slightly missized one in. Those are 50 volts. Those could have been 20 or 35 volts, and they would have been a little smaller, and they would have fit in like this. I went for the same value. I don't think I really had to. What are the other two caps doing? I think they're just on VCC. I think they're just there for stability purposes of the VCC. I wonder if I want to get these out and get smaller ones in there. I can't see anything. There's too many shadows. Probably should have done the whole ring light thing. I don't think I put down any solder there. That was, yeah, it was just loaded up the iron. Wait, that one looks soldered. No, it's not soldered. It can't be. It can't be. That's impossible. Yeah, I got to figure out my lighting situation a little better in here. It's hard to get a light to this side of the table over here. So things can tend to be a little shadowy. And then the light above stuff is back in there. And I guess the best solution for this is just to move in a little bit. But then I'm touching the table too much. And I get kicked off of Turbo Team. That's a little brighter. You can actually see. I wish my dog knew that barking at people with leaf blowers on their backs was not a way to deter them from invading our space. Okay, yeah, there's no solder on the pad. It just looks like it's flown on. It looks like it flowed. Yep. Let's get warm. Oh, this is so much better. You guys got to remind me to move in a little bit. I've got all this workspace in front of this thing. Oh God, the dogs are going crazy. They're a little discombobulated, but they'll figure it out in the oven once I whip out my oven. I don't think we're going to do the oven today just because these parts are coming in the mail. They might get here tomorrow or they might get here Thursday, and then we can finish this build. We finished at least one of the lights, and I'll try to kind of package that a little better. And then we can start looking at the 505, but also we can look at Burn the Subs. Finally get back to Burn the Subs. I really wish I could remove just like the smallest bit of solder from all of these. But it's such a, this is such like a hammer of a tool. It's not very precise. Yeah, see, that's too little solder, I think. R60 is supposed to be a 1206. I just didn't have a 470 1206. It's hard to find 1206s. I mean, we can take a look around and see if we can find any of these components that are sort of elusive, like the 470 1206. So 47 ohms? What is it even doing? It's beer time. Just about. Oh yeah, look at the time. Time flies when you've got a nice, easy soldering project in front of you. This is great. Microcrimes and Ornamentation is a really useful module, and it is laid out in such a way that it's just nice and fun to use. And you get all of this functionality, and when building it, it's just building an electronics kit, which I love doing. So, you know, I have a couple electronics kit projects that I'm hoping to like wrap into the modular synthesizer, like the $30 oscilloscope that we can make into a module. I think that would be kind of a neat thing to have on a rack, and it's only 30 bucks. It'll be kind of wide though, and we got to do weird stuff in order to get it to be modularly formatted. All right, well anyway, we got most of everything in here. I'm just looking for that 47 ohm resistor. Like, what is it doing? Oh, there it is. 4.7. What? Why are we going through a 4.7 ohm resistor? after we go through that. Why would we do that? Because we're going to IC6. So that's for the 3-volt regulator. Or no, that's 5-volt regulator. Huh. I wonder if mine gets hot. I put a very small resistor on there, but I don't think I have... Do I have 4.7 ohms? That's like a shunt. Well, no, my shunts are like 0.00000 something or other. Yeah, this is a 1206 shunt resistor, and it's 0.001 ohm. I mean, we don't need a shunt, but I could put one of those in there. I don't have any of those. I should probably rip the label off of that. Goodbye, INA 169s. You were useful. You are now blank. I do have the 8-pin MSOP shunt amp, though. That stays. So, I also had... Well, no, those aren't... I don't think those are shunt resistors. I had these two. This one and this one. But those are not... I don't think those are 0.4. So, why do I have so many of them? Oh, you know what? These are cutoff thingies. Yeah, those are like current cutoff thingies that you would put on power inputs, although that would be a good place to put one of those things. I don't know how much current this module uses. What did I use for this? 4R7. So that is 4.7. I should probably get this one out of here because 470 is unacceptable. I don't know how the hell I would find a 4.7 1206. I guess we'll scrape something up, but... What I should do is put the current shunt here instead of this resistor. Or not shunt, the current, what, MOV or whatever? Not MOV. What were they called again? I forget. Okay, my brain is turned into mush if you guys couldn't tell, so I guess we're gonna take a break on this thing and we'll get back to it when I have parts in hand, and then we can do our final push to get this thing out, and then we'll wipe. Wait, what did he say? Why did he say it like that? Okay. Yeah, I don't know about removing little bits of solder. I was a little bit too crazy with the solder and it makes it look sloppy. I think what we'll do is when I'm done with this, I will blop a little bit of tacky flux on all of the pins, and then we will throw it into the oven, have it come out of the oven, hit it with the isopropyl, and then it'll look like a brand new factory built board. And then we can move on to do the through-hole soldering. Put multiple smaller ones together. I've done with that with the 10 and 1000. I'm not going to do that. This is fine. These will not blow up because they're not going to see 24 volts. These will not blow up because they're way over spec'd. It's okay if they're just a little bit different. In mine, I used a 4.7 ohm normal size resistor. Not sure if that gets hot, but this thing works fine and it hasn't burnt down my house even once. So I would forgive once, but it hasn't done it at all. This I definitely need to make sure gets into the bin because it's broken. And then this one this one is completely binted, so I need to replace the regulator on it, and then we can put that towards the second spinny light. The spinny light works. We baited both raids. The raids were from Code Rushed, who is a regular raider, and new raider Beats Creations. They raided into the channel before we were able to get the thing working. It was very, very, very frustrating. Oh no, I'm not going to put multiple together and do the math. We've done that before, but I don't need to. So very frustrating. I was using pin 2 of the ESP. Shouldn't have been doing that. It put it into a weird boot mode at the beginning where it was like probably looking for an external like serial signal or something. It did weird stuff. And so we moved it to pin 4. That fixed that. I multiple times put the wrong power in, and that also completely destroyed it. So in spite of my bumbling through the projects, we did finish the raid light. So if a channel were to raid, that would come in through the API, go through Node-RED, and turn this on for 30 seconds so that I could say, hey, welcome in, and 47 people from, Brain Fungular 5000. I really appreciate you. What were you guys working on? And they'll say, we were painting a naked body. And I'll say, oh, cool. While this thing goes off, both in the background, and now that we have the powerful LED in there, it's also fairly visible, the lighting effects on this. We'll be able to turn off other lights as well, so that I can have it go lights out, Gorilla Radio, and then have this thing going off, because I think that's even more amazing, is just to have, I should have them lift up from below. I could put it on a little strut, and it'll say, oh, welcome in. And then, you know, maybe we can put like a digital siren or something like that on it. Man, that is bright. That hurts a little bit. I maybe should have shopped around and gotten a slightly lower wattage LED bulb for it, because that hurts. But I guess it powers over my regular, you know, streaming lights. So, okay. Thank you, everybody. I really appreciate you joining me for just a Friday afternoon of soldering. It's my favorite thing to do. And I hope it's yours too. But here's where we will end card. Bada bing, boom. So you can catch me on not Blue Sky anymore. That got hacked and sent a bunch of like porno stuff, and so Blue Sky went. And then I said, hey, could I get my hacked account back? And they said, actually, they didn't say anything. They didn't get back to me. So, but Discord is pretty much my social media now. Try to stay off Reddit. But yeah, if you guys want to catch me in between streams, that's where you're going to find me, is on Discord. So check it out if you can. If not, you know, I didn't need you there anyway. It's fine. It's fine. I'm not gonna. Should we see if anybody else is on Twitch? I have to like look around my equipment here. Oh yeah, you guys are going to Flatulent Gonad. We're going to raid Flatulent Gonad because he's on right now. I don't know what he's doing, but it should be pretty interesting. So raid, or not. It might not be interesting. Blue Sky account suspended. No naughty stuff. Considering the stuff that's on, I think it was trying to scam email, which is sort of the primary offense. It's like, if it just posted a bunch of porno, that wouldn't have been so bad. The problem is, when I came into Blue Sky, it was part of a giant like thing where you push a button and now you're suddenly subbed to all the electronics gurus. And if I started that account over, I would not be able to get any kind of traction. Gonad was the one that came over with, well, originally like a couple days before, and he got like 300 more followers that I did that way. Pretty cool. Anyway, let's go raid Flatulent Gonad. Let's see what he's up to, and I will catch you guys on Thursday. We will figure something out. I'll probably have gotten parts in the mail. Later. Okay, and now YouTubers, we're going to stop you. Have a good night.